Now, dinosaurs ruled our planet for over 165 million years, and some walk on our planet even today. Well, at least some of their descendants. Our modern birds evolved from what used to be a scary group of meat-eating dinosaurs we know as theropods. It all started during the Mesozoic era, about 250 million years ago, when a group of creatures called dinosaurs roamed Earth. They didn't look like those dinos that might have come to your mind, like Brontosaurus or T-Rex, but that's the group dinosaurs evolved from. These creatures walked on all fours and were as big as house cats. They didn't look as friendly though, considering they were more like weird lizards with long, thin limbs. As you'd expect, this group wasn't exactly at the top of the food chain, but they were really fast and agile, which helped them survive. Over time, they adapted and started walking upright, so their legs were under their bodies instead of out to their sides. And over time, dinosaur morphs started growing long tails and bigger leg muscles. Their necks became stronger to support the new position they were in, and they even got extra hip bones that helped them move faster and more efficiently. That's when dinosaurs came on the scene, somewhere between 240 and 230 million years ago. Their name comes from the word dinosauria, which means terrible lizard. The oldest dinosaur fossils belong to these fellas that lived in Argentina. This one is even older, but we're still not sure if it's a real dinosaur or its relative, dinosaur morph. Now, considering the size of their ancestors, dinosaurs weren't large at the beginning, more like dogs or horses. There weren't many species back then, so if you could go back to that time, you'd see a bunch of reptiles walking around on two legs. But as time went by, they adjusted to different environments, and we got more interesting groups. For example, small and fast predators, like this guy. They all fall into the category of archosaurs, a group that also includes pterosaurs. Yup, their name may not imply it, but these are not dinosaurs. As some dinosaur morphs evolved into dinosaurs, they got certain advantages, like arms. They could do much more thanks to that. Some could catch prey using their hands. Others could grasp branches. Now, the freedom they got by moving their arms later helped some of them evolve into birds and start flying. Dinosaurs were probably warm-blooded. It means they could stay active all the time. They didn't depend on the conditions around them like, for example, reptiles do. The latter are cold-blooded, and they have to rely on their surroundings to regulate their body temperature. Dinosaurs didn't rule the animal kingdom for the first tens of millions of years of their existence either. Crocs were at the top of the food chain back then. Then the Jurassic period hit, and new kinds of dinosaurs showed up, like those giant plant-eating dinosaurs, for example, theropods. You know them, dinos with long tails and necks that could eat plants at different heights, such as Brachiosaurus. Allosaurus is another famous dino from that time you'll probably recognize. Spikes on the tail, bony plates on the back, you know, good old Stegosaurus. The Jurassic period was that time when dinosaurs started to get bigger and bigger. Then the Cretaceous period came along, and finally these magnificent beasts reached the peak of their fame. That was the time when the mighty T-Rex took the throne and got to the top of the food chain. T-Rex probably lived around 28 years, but it reached adult size really fast. Now, it wasn't easy to survive back then. T-Rex falls into the category of tyrannosaurs, and scientists have found out those fellas were fierce even when they were at a pretty young age. They discovered a fossil of a teenage tyrannosaur that was 75 million years old, and it had two baby dinosaurs inside its stomach. They realized that when tyrannosaurs were at a young age, they went for small dinosaurs, such as these guys, their dino cousins. As they grew older, they started taking on bigger challenges, like those peaceful giant dinosaurs that like to hang out with their group and eat plants. But large predators weren't the only ones that would have made you shiver with fear. That was also the time when fast and smart creatures called velociraptors show up. They weren't some scaly dinosaurs that would catch their prey using those claws in the shape of sickles, like shown in the movies. Their bodies were covered in feathers, and they would grow up to 100 pounds, which is about the size of a wolf. And to bust one more myth, they didn't hunt in packs. Velociraptors probably preferred to hunt solo and use their claws not to slash their prey, but to clutch it. T-Rex and Velociraptor fall into the group called theropods. We mentioned them at the beginning, the creatures today's birds evolved from. But even though velociraptors were covered with feathers, they still couldn't fly. Their wishbones weren't shaped in a way to support flying, and their arms were too short. Maybe it was better that way because during the Cretaceous period, flying dinosaurs called pterodons were the ones that took over the skies. Things had been going really great for dinosaurs until one unfortunate day 66 million years ago when an asteroid hit our planet. It's not that the asteroid itself erased all the dinosaurs right away, but it caused changes in the environment, which made it way harder to survive. At that time, about 75% of animals living on our planet went extinct. The asteroid was really big. When it hit Earth, it created a giant crater in the Yucatan Peninsula and sent a lot of debris into the atmosphere, which blocked the sun right away. For months, dense clouds of dust blocked sunlight. Our home planet was darker and colder than before, which wasn't good for plants. Creatures that ate plants couldn't survive those changes either. So it all turned into a chain reaction when most of the ecosystem collapsed. When the dust finally cleared, all those greenhouse gases that had formed after the impact made temperatures go way higher than they had been in a really short period of time. All land animals that weighed more than 55 pounds were gone. But not everything disappeared. There were fewer plants, but they were less affected than animals, all because their pollen and seeds can survive really messed up conditions for a longer time. So, what we have today is basically the seeds we were left with back then. After the asteroid hit, flowering plants dominated our planet. All non-bird dinosaurs went extinct too. Some species survived as birds. At first, those brave survivors were small, but later, birds evolved to bigger sizes. Now, there's a study that says that if the asteroid had slammed into some other spot on Earth, the fate of many creatures and plants would have been very different. If the rock had fallen maybe a couple of minutes later, it would have hit deeper waters. Less rock would have vaporized and risen to block out the warmth and light coming from the sun. In that scenario, we'd probably still have dinosaurs around. For example, Triceratops was one of the last dinos that had nothing in common with birds. If the asteroid had missed our planet, we would see some of them still roaming around, but since evolution never rests, maybe in a little bit different form. Hundreds of dinosaur species roamed our planet, and researchers give a name to a new type approximately every 2 weeks. It's not fair to stick to T-Rex, Stegosaurus, Spinosaurus, and other famous sauruses all the time. They've had their chance to shine in the movies and across the internet. So let's check out dinosaurs that no one talks about. First on our list is Pterosaurus. The special thing about this dinosaur is that it definitely had one of the largest skulls ever found. It was big because of this frill going from the back of the animal's skull and covering its neck. The frill wasn't there for protection. It was probably just to show off a bit. The bone in the frill was thin and full of holes. As you can see, it's very similar to Triceratops. There are still debates about whether these two are the same species, but more and more studies show that they were more like cousins. They were probably similar in size, but Pterosaurus had a longer head with big openings, as well as longer frill bones with a groove on top. It also had more pairs of horns on the back of the frill. Some like to call Pterosaurus a bull lizard. These fellows were plant eaters that may have lived in social groups. They existed at approximately the same age, but Pterosaurus somehow ended up on the less popular side of the family. Kentrosaurus was a small stegosaurus. It's one of the least cuddly dinosaurs of all time. Its long, thin spikes seem to be a pretty good defense mechanism. Stegosaurus, on the other hand, had shorter, thicker spikes that were less likely to bend or snap when the animal used them. Now, you wouldn't want to get anywhere near Kentrosaurus, though. Its tail could swing in a big half circle and hit with a force strong enough to break a human skull. Any volunteers? No? Okay. One scientist used scans of the dino's fossils to make a computer model of its skeleton. The model showed that Kentrosaurus had a flexible neck, It must have been really useful for looking around to see if something interesting was going on or if there was any dangerous animals trying to sneak up. Quetzalcoatlus typically walked on all four legs with straight hind limbs. The computer model tells us it could spread its front legs out to its sides too. Maybe it was a way to protect its belly during fights. Stegosauruses, in general, had tails that were like big weights at the back of their bodies. That's why their balance point was closer to their hips. That's also the reason why they could easily stand on their hind legs and swing their tails around. So most people haven't heard of Heterodontosaurs, even though their fossils show that dinosaurs got feathers way back before we thought and in groups where we didn't expect it. In 2008, paleontologists identified the first known skull of a baby Heterodontosaurus, which was less than 2 inches long, smaller than a tea bag. This baby dinosaur had relatively big eyes and a short snout compared to bigger ones of its kind. Now, what's really interesting is that some scientists used to think that Heterodontosaurus's tusks, like those of modern warthogs, only appeared when they were fully grown. But it seems they had them from the early stages of their life. Heterodontosaurus had 5 fingers on each hand, 2 of which were opposable. It was a good tool, considering the animal probably ate both plants and meat. Humans have different types of teeth, some for biting, some for chewing, and also canines. But most reptiles have just one kind of teeth. Heterodontosaurus was special because it had 3 different types of teeth: small peg-like ones, big teeth resembling canines, and square-shaped teeth that did the cutting job. Scientists are not entirely sure how this creature used these different types of teeth. Maybe it was for digging up roots, breaking into termite nests, or even defending themselves against dangerous animals. Okay, say this name with me now: Stegosaurus. She was quite a common dinosaur in its time, but she never still gained popularity. Scientists found out that when these dinosaurs were young, they probably crawled, considering they had longer arms and short legs. But as they got older, between 4 and 6 years old, their hind legs started growing much faster and became much longer than their front legs. So, later in life, they likely didn't move on all fours anymore, but walked on 2 legs. Inside the stomach of one of these creatures, scientists found pebbles. This shows the animals either had a hard time digesting what it ate, or it didn't chew its food very well. Its beak looks quite familiar. That's how it got its specific name, a parrot lizard. It was really strong, and some believe the creature used it to crack and open tough nuts and seeds before the pebbles in its stomach helped mash them up for digestion. These guys might have been good at swimming. They had broad feet, and the shape of their tail could have helped them move in the water relatively easily. Some scientists even believe they might have spent most of their lives swimming in rivers and lakes. In 2004, researchers found something really sweet: 24 young parrot lizards huddled together. They were too big to be hatchlings, so it could be a bunch of teenagers who had left their nests and then formed a group where they could support one another and defend themselves better. But apparently, that plan didn't work out so well. Now, check this one out: Stygimoloch, or as they call it, Styx demon. We're looking at a peaceful plant-eating creature with bony spikes and knobs on its skull. Most scientists believe it was a younger form of this fellow, even though they used to think they were a separate species. Stygimoloch is smaller than its more popular cousin, but it's also more robust and has a pretty thick neck. This dinosaur, with small forelimbs and long hind legs 3 feet high, which is half as high as an average human. That doesn't sound dangerous in the world of giant and fierce dinosaurs, but the animal had a very thick skull roof. Maybe it wasn't the strongest tool to defend itself, but it probably helped in combat with rivals from its own species. They most likely headbutted to win the hearts of their chosen ones. But rivals from its own herd were a piece of cake compared to the predators that might have gone after it. After all, this dino lived at the same time as old T-Rex. Now, when someone tells you to picture a dinosaur, Chisaosaurus would probably be the last thing coming to your mind. It looks as if you've put together pieces of random animals and tried to make your friends believe this truly was a real animal that once roamed the earth. But it's actually a dino, with giant sharp claws on its forelimbs, a bulky body, and a long neck ending with a tiny head. Now, don't let the claws scare you though. These creatures didn't go after other animals since they were herbivores, but these claws could protect the animal from intruders and predators. The full scientific name of this creature describes it as a giant sloth-like reptile from China. This animal was one of the biggest and oldest members of the group where it belonged, which lived around 115 million years ago. No, I wasn't around then. At first, it was hard to tell which animals were related to this weird-looking dinosaur. But in the 1990s, scientists made a conclusion that they were modified plant-eating theropods, which is similar to carnivorous dinos. They also most likely had feathers and small wings, like some sort of a very big turkey. Now, thanks to new fossil discoveries and technologies, we're getting to learn more and more about the biology of dinosaurs. Some people don't need to know more than the fact that a few of them were colossal, terrifying, and vicious. But for those of us that do, the use of comparative biology, pigment analysis, and powerful new X-rays have allowed us to gain insight into specific features, such as their colors, eating behaviors, and the shapes of their tongues. Yes, that's right, the shapes of their tongues, which, for a long period of time, was something of a mystery. This is because soft, fleshy dinosaur parts are hardly ever retained in fossil form. But thanks to the discovery of some surviving hyoid bones, which are situated at the root of the tongue in front of the neck, we now have some insight. Most animals have this hyoid bone that anchors the tongue. The shape and complexity of the bone determine how free-moving the tongue can be. Scientists have discovered that nearly all dinosaurs had simple tongues that laid flat and were extremely similar to the tongues found inside the mouth of a crocodile today. Yeah, this crocodile. Go ahead and take a closer look. Nah, just kidding. Come on back. Let's take a look at some specific dinosaurs and start with the Brachiosaurus. Let me stick my neck out on the line by guessing that most of you will be familiar with this dinosaur because of its neck. You know, the one which was typically 30 feet in length. Despite its neck being its most distinctive feature, its name actually translates to arm lizard in Greek. It's common knowledge that the Brachiosaurus is one of the largest dinosaurs to ever have lived. On average, it reached 76 feet in length and 40 feet in height. That's roughly the length of 2 school buses and as high as a 4-story building. None of which were around in the era of the big guy here. Fragmentary leg bones and vertebra of even larger dinosaur species are known, but these skeletal remains are too incomplete to determine their exact size. So this guy may have been the largest dinosaur ever. A renowned herbivore, thank goodness. The Brachiosaurus is thought to have eaten up to 880 pounds of dry plant matter every day. Most of this was made up of coniferous trees, ginkgos, and cycads. This target might have been hard to hit for this dinosaur, as researchers have learned that its teeth were spoon-shaped and not ideal for chewing food. This means that the creature would have swallowed vegetation whole, as its teeth were suited to stripping it but not breaking up large chunks of plants. This, along with the dinosaur's body shape, suggests that the Brachiosaurus would have liked to feed as quickly as possible. Dinos like these didn't always make use of their ability to strip towering trees when dining. The Brachiosaurus traveled in herds, moving to the next location once they had exhausted all of the local vegetation. And I mean all of the local vegetation, not just that which hung high on trees. It's likely that the creatures supplemented their diets with vegetation at lower levels, especially after they'd done a number on all the nearby trees. This method of feasting was the most energetically appealing for this giant. By munching on lower vegetation, Researchers believe that the dinosaurs saved up to 80% in energy compared to when foraging for high-up food sources. They have also discovered that the nostrils of a Brachiosaurus were on the front of its face and not the top. This is because we now know they roamed the fertile floodplains in their respective herds. For decades, it was believed that these creatures lived in deep, watery swamps. Let's look at another common misconception about a popular dinosaur. Please put your hands together for the Tyrannosaurus rex, which is arguably the most famous of all dinosaurs. Discoveries from the past 100 years have revealed that theropods had heavily feathered skin. Theropods are the family of dinosaurs to which the T-Rex belongs, so naturally, people began to think that the creature would have been covered in feathers as well. However, a study from 2017 took skin impressions from the iconic dinosaur and found no evidence of the structures required to support feathers. If a T-Rex did have feathers, they would have been limited to its back. Researchers accept that other large dinosaurs of the same family as the T-Rex have been discovered with their remains covered in feathers. An example of this would be the Yutyrannus dinosaur. But as of now, the accepted theory is that feathers weren't a common feature of T-Rexes. This makes it easier to believe that feathers were exclusive to smaller tyrannosaurids and were there as a means of keeping the creature warm. For a long period of time, researchers thought feathers were an exclusive feature of the theropod family. But this theory has been debunked. Just like the kid at camp who was kicked out of the top bunk. You know, debunked. Anyway, fossil evidence discovered in Siberia now suggests that multiple different family groups of dinosaurs had feathers. The Siberian fossils in question belong to another species of dinosaur, Kulindadromeus zebicolicus. Oh, you think I mispronounced that? Okay, prove it. Now, this dinosaur, I'll call her Kulinda, had a pelvis structure superficially similar to that of a bird and was roughly 4.5 feet long, about as tall as a fridge. Since the purpose of feathers on dinosaurs was for warmth, it's quite possible that dinosaurs from cold weather climates had more feathers than their counterparts in warm weather climates. In general, bigger animals struggle less with keeping themselves cool, so it's likely that any of the large dinosaurs who lived in these warm climates had no feathers at all. Smaller dinosaurs who lived in cold climates, on the contrary, had plenty of feathers. We now even understand what some of the designs and patterns of these feathers on dinosaurs looked like, thanks to the discovery of an ornithomimus, complete with feather and skin impressions. The name of this dinosaur is derived from Greek and actually translates to bird mimic. They were typically 11.5 feet in length, nearly as tall as a giraffe, and despite being omnivorous, had no teeth. Its other distinctive features include 3 fingers, which were all unusually the same size and length, and despite their thin-boned skulls, they also had large brain cavities. Their legs were extremely long, in particular their foot bones. Combine this with their toothless beaks and long necks, and yep, it must have looked a lot like an ostrich. Although they're not as big as the Brachiosaurus or dinosaurs in general, they are bigger than any other bird in the world. And it wasn't just the body limbs of an ornithomimus that made it resemble an ostrich. They also had very similar feather patterns. Their heads, necks, and lower legs were mostly bare of feathers, but the rest of their bodies were well coated in downy plumage. This is what you call a bird's layer of feathers as a whole. It's possible, like an ostrich, that the dinosaur would have used this unusual feather pattern to regulate its body temperature. Despite some dinosaurs possessing feathers like birds, on top of also being their distant relatives, dinosaurs didn't have the type of feathers required to fly for most of their existence. Feathers found in fossil impressions or preserved in amber have allowed researchers to gain insight into why these creatures weren't very aerodynamic. The structure of these feathers appears to be very simple, with a poorly defined and flexible central shaft. These feathers would have better served any dinosaur as a fashion statement, as they would have helped attract the attention of other dinosaurs. These feathers also would have had the ability to regulate body temperature. Surprised to hear that dinosaurs had ostrich-like feathers? Wait till I tell you that their prehistoric distant reptile cousins had something that looked like fur. Allow me to introduce you to the pterosaur. Its name is derived from Greek and translates to winged lizard. Just like dinosaurs, they were initially thought to have scaly or leathery skin all over their bodies. But over the course of the 20th century, fossil examinations revealed that many parts of a pterosaur's body were furry. The wingspan of a pterosaur could reach the length of over 23 feet, about as long as a London bus. Its toothless jaw was very long and resembled that of a pelican. How could something that looks like a pelican be so terrifying? These creatures were coated in pycnofibers. Those were simple structures, feather-like in composition, but strand-like and fuzzy like fur. Further research suggests that some parts of the pterosaur's body had more complex kinds of feathers with branching strands. If this is accurate, it would be the first time feathers were found on an animal that was neither a dinosaur nor a bird.
Are you sure that it was an asteroid that caused the extinction of dinosaurs? There's this huge drama about why these horrifying creatures disappeared. It's a big deal in both science and movies. But what really happened to the dinos? How do scientists figure it out? And why does it even matter? Let's see. Let's take a trip back to England in 1842. There was a scientist named Sir Richard Owen. He was checking out some huge reptile fossils and noticed that 3 of them, Megalosaurus, Iguanodon, and Hylaeosaurus, had a lot in common. So he had this light bulb moment and decided to combine all these creatures into Dinosauria, which means terrible lizards in Greek. The scientists were studying dinosaurs and grouping them based on their looks. But then, Charles Darwin showed up and gave even a better idea. Turns out, species don't just appear out of thin air, they evolve. And now, everyone had to rethink how they were defining dinosaurs. They came up with a new idea called phylogenetic classification. Picture a big family tree with all creatures ever. Somewhere up there, we find Megalosaurus and Iguanodon. And we say all dino descendants come from their common ancestor. It's like tracing back your family tree, and if we go far enough, we find the ultimate dino ancestor. Sounds like a plan. But then, things got a bit complicated. When we talk about dinos, we've got the ones with feathers and beaks and the ones without. That's when we found out that birds are cousins to certain dinosaurs, maybe even evolved from them. After learning that, scientists had to look at the bird family tree and rethink the dino definition. In the end, they decided that birds are kinda dinosaurs, but not exactly. Confusing, huh? But in any case, now we have 2 groups. The first one is birds, and the other one is non-avian dinosaurs, which are extinct. That means now we have to reconsider our question. Instead of asking what caused the extinction of dinosaurs, it should be what caused the extinction of non-bird dinos. The answer might seem simple. People often think of a gigantic space rock as the dino destroyer. It's probably the first thing that pops into your mind. Even Google and other search engines agree on this one, like best friends copying each other's homework. History teaches us that about 66 million years ago, dinosaurs totally vanished, except for the ones that became birds. Of course, the truth is more complicated. And not all dinos vanished in one go. Some went the natural way, and there were many extinctions here and there during their time on Earth. But the big event we're talking about looks like a movie scene change. Like suddenly changing the channel on a TV. One poof. And the Earth went from the time of dinosaurs to the time of mammals. Scientists call these time periods the Cretaceous and Paleogene. We even give this special event a nickname, the KPG, or KT extinction. Some even refer to it as the 65 million years ago event, even though the more correct number is 66 million years ago. We've got 2 main theories in the spotlight: asteroids crashing and volcanoes erupting like crazy. let's talk about the asteroid idea. So, around 66 million years back, imagine a humongous asteroid smacking into Earth. This thing was about 6 miles wide, about as big as Mount Everest. It zoomed through the sky super fast, like a mountain going 100 times the speed of sound. And when it hit, it released a ton of energy. It crashed down in what's now southern Mexico, near a spot that's tied to the dinosaur extinction story, Chicxulub crater. Everything close to the impact was zapped into vapor in a snap. Picture the biggest energy burst in ages, like 1 billion years or more. Nothing near the crash site stood a chance. Next, there was the aftershock. As the fireball cooled down, the Earth's surface went bonkers. The ground twisted and shook, causing unimaginable earthquakes. The continents became huge, bouncy castles. And then, the stuff that got blasted up by the impact came raining back down like a rainstorm. Even if you weren't near the huge pieces falling in Mexico, you'd get hit by these smaller, super hot bits flying through the air. This made the air so toasty that forests burst into flames all around the world. Are you ready for more? Time for a massive tsunami. The ocean floor got all churned up, pushing waves inland around the Gulf of Mexico. But just imagine, even all that wasn't enough to destroy all the dinosaurs. For example, dinos in New Zealand were pretty fine, but we know that they all went extinct. So what happened to them? They felt a little rumble, and suddenly, the sky started getting all dark and gloomy, as if it was nighttime. And hold up, what's that? A blanket of ash is slowly creeping around the whole planet. Now, here's where the real drama happens. The big problem with the asteroid crash wasn't the instant boom you might think. It's all about the long-term effects. Imagine the stuff that got blasted up into the sky blocking the sunlight. Days turn into nights, and temperatures drop very sharply. A lot of plant-eating dinosaurs passed away, and hunters were having a great feast, but not for too long. Without sunshine, the food chain falls apart very quickly. Then, the ash falls back to Earth. Things go from bad to worse. Other nasty stuff starts floating around in the air like carbon dioxide. This carbon dioxide mixed with shattered seafloor bits makes the temperature go wild. The Earth was playing hot and cold all at once. That's when somewhere between 50 and 80% of dinosaurs said goodbye forever. What's even more sad is that this number only counts the species themselves. If we look at the number of individual animal lives lost, it's even higher. You might think that at least the poor mammals finally got their chance after the dinos left. But even mammals had a tough time. We are very lucky that a few brave mammals managed to survive this crazy chaos. The ones who made it were like the little champs with speedy energy systems, flexible diets, or secret hideouts. But this story is only one hypothesis. Next, we have the volcanism hypothesis. Volcanoes, these fiery mountains, are used to spitting out molten rock and causing epic destruction. But surprisingly, this theory isn't about explosive eruptions. Nope, it's about something sneakier and slower. Around 1 million years before the dino doom, there's this big change happening under the Earth's surface. Way below where India's floating, a rock river starts forming, heating things up. And then, India gets hit hard. It turns into a sea of lava, like a fiery ocean. It's like a gazillion of dump trucks filled with lava slowly pouring out. These solidified leftovers are known as the Deccan Traps, like a super deep layer of hard lava covering a piece of land the size of France. And just like in our asteroid story, the real trouble comes from the air. For hundreds of thousands of years, sulfur dioxide spread like an unstoppable shadow. It was making the sky gloomy and the rain toxic. Food sources turned into poison, and oceans became acid baths. And then, carbon dioxide took the stage. It was like a temperature button, flipping the Earth's climate upside down. It was a roller coaster of chaos. The ecosystems were stressed, food chains snapped, and species waved goodbye one by one. Both theories seemed pretty realistic. All the experts were having a big debate about which theory was correct and why the dinos disappeared. So, what is the real answer? Unfortunately, we don't know. Some scientists support one theory, some support the other one, and we're left scratching our heads. But hey, don't be too hard on the media or the scientists. They're all doing their best to figure out the mystery of the dinosaurs' disappearance. And maybe one day, we'll finally learn the real answer. So, stay tuned.
Hey, it's possible that Jurassic World is not just a fantasy. Dinosaurs could really be walking, swimming, or flying around somewhere out there, but not on Earth. Some scientists think there may be planets far, far away from our solar system where slightly different versions of T-Rex and other dinosaurs live. They got the idea based on the fact that our planet used to have about 30% higher oxygen levels than today. That's why complex and intelligent life forms like dinosaurs could develop in the first place. They also want to explore basic building blocks that are the reason why we have life on Earth. These building blocks are something we know as amino acids. They make proteins, sugars, and genetic material, RNA and DNA. They're consistent and mainly exist in one shape or orientation. There are two ways they can be oriented, right and left. That means they mirror each other, just like our hands. It's something we call chirality. For life to exist, proteins must have one form, which means they can be oriented right or left. On our home planet, almost all living things, from the smallest bugs to whales and elephants, have amino acids with a left-handed orientation. We're not exactly sure why things are set that way, but there's a theory that's because of meteorites that crash-landed on Earth 4 billion years ago. They brought specific kinds of amino acids and some other organic materials to our planet, and somehow set the pattern we have today. Maybe we could use special telescopes we created to search planets, especially those where conditions are similar to how they used to be on Earth back in time when dinosaurs existed. In that case, it would be better to watch them from a safe distance, because, considering what they might look like, researchers say it might be a safer choice. That's a cool idea, but it's still very tricky. The history of life on our planet, especially that of dinosaurs, involved many catastrophic events and mass extinctions. There's always more room for new theories about dinosaurs. One of them says oil comes from dinosaurs. Interesting, but not true. Oil formed from the remains of sea animals and plants from millions of years ago. This was way before dinosaurs appeared. Tiny organisms ended up at the bottom of the sea. As bacteria decomposed animals and plants, they removed most of the oxygen and some other elements from them. It left behind only a sludge, which was mostly made of hydrogen and carbon. As time passed, those remains became covered with many layers of silt and sand. When the depth of the sediment increased to 10,000 feet or even more, heat and pressure turned the remains into natural gas and crude oil. It's possible that dinosaurs lived or fell in the sea and later became petroleum in the same manner. But no one has ever found crude oil containing their skeletons. So this is just an unproven theory. Then there's the feathered dinosaur theory, which, unlike the previous one, seems to have more foothold in reality. Back in 2010, researchers found evidence that 100 million years ago, there had been a dino species with ginger feathers. Another group of scientists claimed there had been a different species from 150 million years ago. Those dinos had freckles and reddish-brown feathers on the tops of their heads. The color patterns probably had their purpose. Maybe it was a way to communicate with other representatives of their species or to attract mates. But years later, scientists studied the Microraptor, also called a feathered dinosaur. They realized it had probably been more like a bird than a dinosaur. The key point is how birds replace their feathers. Birds that fly have to replace their feathers in a specific order, otherwise they won't be able to fly very well. And the Microraptor's fossils showed that this creature had changed its feathers in a similar pattern. so they're not really sure which category this animal falls into. Dinosaurs that had feathers shed a lot of their skin piece by piece, like dandruff. Hey Bob, looking a little flaky there. Need a new shampoo? Yeah, they didn't shed their skins like lizards do, as if they take off an old suit. When we talk about dinosaurs, we usually don't picture them as social creatures, more like isolated ones similar to lizards. But some researchers discovered an 80-million-year-old collection of clutches in the Gobi Desert. It means there were colonies of dinosaurs that protected their nests and guarded their young, similar to birds. Crocodiles are known for doing that too. Pterosaurs were flying dinosaurs, and pelycosaurs were fin-backed ones. Some studies have shown that these two species used their exaggerated head crests and sails or fins to get to their potential partners. There are many theories about their crests and what they were needed for, though. Some experts believe that was how dinosaurs regulated their temperature. Others think they needed a crest to steer through the air. It's hard to say anything for sure since their fossils are rare and they don't have living descendants. But the most likely option is that the crest had the same purpose as a peacock's tail and was used for selecting mates. The bigger the crest, the more chances a pterosaur had to get a partner. You know theropods, those scary meat-eating predators that are shown in most dinosaur movies? Well, they might have enjoyed eating plants way more than tearing flesh. Not all of them, but it's possible that many of them weren't as fierce as we might think. Those big scary ones, like T-Rex, could be exceptions rather than the rule. The thing is, movies show these creatures to be way faster than they probably were in reality. They could probably run just a little bit more quickly than the average human runner. Scientists study the diet of coelurosaurs. Those seem to be the closest relative to birds. It was hard to figure it out because some of the dinos from this group had peg-like teeth, or in some cases, no teeth at all. To understand what they ate, researchers had to look for direct evidence and check if there was anything in their stomachs. And after they discovered certain things, including a beak with no teeth, they realized these fellas had followed a vegetarian diet most of the time. Even some famous ones, such as velociraptors, could be just innocent plant eaters and not terrifying beasts from Jurassic Park and our childhood nightmares. Over 10 years ago, scientists found fossils of a small dinosaur. It was a creature as big as a parrot with long legs. It came from a family with some of the most famous predators we know about, such as T-Rex and Velociraptor. Most dinosaurs that lived on land had 5 fingers, but later some of them ended up with fewer fingers. This new one they discovered was special because instead of having 3 fingers, which was more common for its family, it had just 1 finger with a sharp curved nail at the end of each front limb. This creature probably used this 1 finger to dig into insects' nests to feast. Even though we know all about the asteroid that wiped out dinosaurs, some have other theories. One paleontologist even had an idea that dinosaurs had possibly reached their end because they had been eating one another. This especially worked for ancestors of fierce, scary predators such as the Tyrannosaurus rex. It's possible they ate so many eggs of other dinosaurs that many species just went extinct. Once they started eating the eggs of very big dinos that we know as sauropods, it's possible they started getting bigger too. And no dinosaur mother could stop them from eating her eggs because she couldn't be around all the time. There were other big predatory animals that ate eggs, even early mammals. But in any case, later research showed dinosaurs couldn't have eaten enough eggs to have caused mass extinction. And that's all I have to say about that.
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dinos' bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with Diplodocuses or Brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as Ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Ah, wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and Pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050?
66 million years ago, I wasn't around then, a huge asteroid hit the Earth and triggered the mass extinction of almost all living creatures on the planet, including dinosaurs. Had the space object crashed somewhere else, some dinosaurs would have been able to survive and still live nowadays. According to some research, the asteroid had about 1 in 10 chances of wiping out the dinosaurs and other animals of that time. It was way more likely to just hit the ground without any strong destructive consequences. To understand how things could have turned out if the place of the collision had occurred elsewhere, we need to find out what happened that day and why the disaster turned out to be so devastating. This huge space rock fell into the coastal area of the Yucatan Peninsula in Mexico. This caused a chain reaction that triggered natural disasters around the world. The place the asteroid hit is called Chicxulub Crater. Now half of this area is underwater. The asteroid was about 7.5 miles in diameter and moving at a speed of 27,000 miles per hour. This rock, bigger than Everest, was rushing toward Earth faster than the speed of sound by almost 40 times. Wow. The energy released in the collision was as powerful as an explosion of about 10 billion atomic bombs, and the destructive force of the blast wave was just one of several disasters. The asteroid happened to fall in one of the worst possible places, and because of the way it fell, it threw a huge amount of dust into the air. Imagine you're jumping into the water like a professional athlete vertically, leaving hardly any splashes behind. And now think of how much water splashes when you jump into the pool like a cannonball. So the asteroid landed the cannonball way. The second disaster the asteroid provoked was soot burning. A small part of the Earth's surface consists of rocks. Only a tiny percentage of that part was rich in oil and sulfur back then. The asteroid burned and lifted so much soot into the air that it would be enough to fill an indoor baseball stadium. According to research, 65 million years ago, only 13% of the surface of the entire planet could have contained the necessary amount of organic material for the formation of such a volume of soot. That's why this place was considered the worst. If the catastrophe had happened on the territory of the other 87%, then dinosaurs would have been alive today. A huge cloud of soot and carbon dioxide rose into the air and covered the sun. The soot turned the sky gray and partially blocked sunlight. This led to a quick drop in temperatures almost all over the planet. It seemed like Earth was inside a gray veil. Many plants and animals couldn't survive the cold snap. Trees began to wither because of the lack of sun. The photosynthesis process was disrupted. The cold and withering of trees led to another catastrophe: global famine. Herbivores couldn't survive because they lost almost all of their food. Plants, flowers, and trees didn't manage to get through the catastrophe. These destructions spread far beyond the asteroid impact site. Hot dust particles, asteroid chunks, and small pieces of rocks settled to the ground across the continent and caused large-scale forest fires. Burning trees threw even more soot into the air, which made the situation even worse. The huge asteroid brought heavy metals with an increased level of toxicity from space. The melting of these substances during the collision provoked firestorms. The asteroid didn't only hit continental land but also water, which triggered a huge tsunami. But that's not the worst part. The seabed was filled with sulfate, and when the energy of the asteroid burned it, it provoked the release of sulfuric acid into the atmosphere. The acid cloud mixed with a cloud of soot and began to spread throughout the sky. Hot rock particles were falling to the ground like fire rain. An acid rain started because of sulfur. It lasted for almost several days and left no chance for the animals to survive. Acid rain made the water in rivers, lakes, and seas poisoned. The acid destroyed anything that couldn't burn. A part of the clouds went to wreck the land, and the other part, the ocean. This made the situation even worse, as sulfur droplets wiped out a huge amount of seaweed and phytoplankton. The ocean generates almost half of all oxygen reserves on our planet. Those days, the sea creatures living in its upper parts were destroyed. It wasn't the blast wave, but lack of sun, acid, darkness, and cold that became the main reasons for the extinction of dinosaurs. But even when some lizards escaped from fires and sulfur, they met the sea element. The asteroid impact caused large-scale tsunamis across the planet. The very first wave was around 1 mile in height. That's almost 3 times higher than the Empire State Building. Billions of gallons of water were moving at 90 miles per hour. A wave this strong could easily destroy half of New York today. The meteorite created a series of waves 52 feet high. Massive walls of water the size of 5-story buildings collapsed on the shore and demolished everything in their path. Lack of sunlight, temperature drop, acid and fire rains, reduced oxygen production, forest fires, giant tsunamis, and the explosive wave with the power of 1 billion atomic bombs. All this reduced the biological diversity of Earth by 75%. Yeah, that'll change your climate for sure. Giant asteroids used to hit Earth before, but they never caused such disasters all over the planet. What if this asteroid had fallen into another place, say a forest, far from water and mountainous terrain? This would have caused severe fires. A huge black cloud of ash would have risen into the sky and obscured the sun. But it would have unlikely generated acid or fire rains. Most of the species of the planet could have survived this catastrophe. What if the meteorite had fallen somewhere among the ice and snow? This would have provoked a rapid increase in temperature across the planet. Huge tsunamis would have sunk big tracts of land. However, ash and sulfur dioxide wouldn't have filled the sky. Acid rain wouldn't have hit the ocean. Many marine creatures could have survived and lived to this day. And dinosaurs, far from the oceans, wouldn't have noticed the meteorite fall at all. Probably the most terrible events would have occurred if a meteorite had fallen on an active volcano. This would have triggered the largest lava release in history. Destructive earthquakes would have begun, and the whole sky would have been covered with volcanic ash. What if the meteorite had hit some desert? It would have melted billions of tons of sand and turned it into glass. Just imagine glass dunes that heat our planet even more. And we could dig up the well-preserved remains of ancient lizards out of the glass. Anyway, there were many different possible catastrophic scenarios, and the worst of them came true for the dinosaurs. They are unlikely to return, although perhaps they can be reborn. Scientists were inspired by an idea from a famous Hollywood movie. They wanted to find a mosquito that got stuck in amber. They would extract dinosaur DNA from it. But there was a problem with this. The oldest DNA sample they managed to find was 1 million years old. Dinosaurs were extinct about 66 million years ago. Besides, DNA is a very fragile thing. The probability that it could have been preserved intact somewhere for so long is very small. So, instead of searching for this ancient dinosaur DNA, scientists decided to take DNA from the closest ancestors of these lizards, birds. Over millions of years of evolution, dinosaur paws could have turned into wings, and elongated mouths could have become beaks. Pelicans are very similar to pterodactyls, ostriches resemble velociraptors, and chickens are very much like T-Rex. Okay, let's just stop and imagine for a moment a chicken the size of a T-Rex.
Hey, you want a piece of me?
Now, the common chicken is recognized as the closest relative of the huge lizard. Remove the plumage from it, cover it with scales, give a toothy mouth instead of a beak, and attach a long tail. And you get a real mini Tyrannosaurus rex by body structure and movement. Deep in its DNA, there are similar genes that formidable predators have. With the help of genetic engineering, scientists plan to play with its DNA and try to reverse the evolution, which means breeding dinosaurs can become a reality. Well, that could come back to bite you.
It was a 40 feet long and 12 feet tall beast, the king of dinosaurs. Its massive and muscular body weighed up to 8 tons. Its serrated teeth were sharp, and its jaws had a bite so strong they could crush a car. The creature had 2 powerful legs. It lived in forested river valleys all across North America, almost 70 million years ago. I'm talking about the most famous movie star among dinosaurs, T-Rex. It was very smart, with a brain twice as big as that of any large meat-eating dino. It was slower than other hunters, developing a speed of up to 12 miles per hour. Its other weakness was its small arms. Some scientists think they were just an evolutionary leftover, like the pelvic bones of some snakes. But others believe T-Rex used its arms to hunt. Its 4-inch claws helped the animal out. T-Rex was undoubtedly frightening, but surprisingly, there were even scarier dinosaurs in the past. Around 100 million years ago, there was a giant creature with the name that meant a spine lizard. It was Spinosaurus, the largest carnivorous dino. It was bigger than T-Rex and could grow almost 60 feet long. Its weight could be as great as 22 tons. The animal had long spines on its back. They could grow up to 7 feet long and were connected by folds of skin. They formed something that looked like a sail. Some scientists think it was a hump Spinosaurus used to store water. This dino had dense bones and short hind limbs. Researchers believe that these dinos could use their flat and wide-clawed feet for paddling. This was the first dino that could ever swim. Unfortunately, it couldn't process smells like most other theropods. These were a group of 2-legged carnivorous dinosaurs that appeared on Earth 230 million years ago. That's why the animals the creature hunted could hide from it on land. The Spino dino spent most of its time in the water. It roamed the swamps of North Africa and mostly fed on fish, big prehistoric sharks, and sometimes other dinosaurs. It had a long, thin, and narrow snout like a crocodile. Unlike other dinos of its kind, which had curved teeth, Spinosaurus had conically shaped straight teeth. Giganotosaurus, which is the Greek word for giant southern lizard, was considered the largest meat-eating dino until Spinosaurus was found. It lived around 100 million years ago in South America, around 30 million years before T-Rex appeared there. It was longer and taller, but more slender than T-Rex, and while T-Rex had 2 fingers, this giant had 3. It walked upright on its 2 big and very strong legs. Its tail was pointed and thin, which helped the creature make fast turns while running and keep its balance. The animal could move at a speed of up to 31 miles per hour. T-Rex's maximum speed was 25 miles per hour at the most. Any faster than that, and the giant could lose its balance and fall over. Giganotosaurus had 2 arms with sharp claws. It was mostly an opportunistic meat eater feeding on everything it found on its way. Its bite wasn't as strong as T-Rex's, but it still managed to deal with some bigger animals, like herbivore dinosaurs. Maybe there was even an Argentinosaurus among them, the biggest animals ever found. It's hard to imagine how Giganotosaurus could take down a 50-ton beast on its own. That's why scientists think they may have hunted in groups. The animal's only weakness was its small brain. It was twice smaller than T-Rex's. This means the T could at least win a chess game. Big retractable sickle-shaped claws in the creature's feet are great for cutting. Ladies and gentlemen, welcome Utah Raptor. That's a mini T-Rex that lived 125 million years ago. If a big T-Rex was coming for you, you could hide under a rock or some other place where it wouldn't be able to reach you. But there would be no place where its mini version couldn't follow you. Discovered in Utah, strong, toothy, and armored with huge claws, more than 9 inches long, an adult Utah raptor was 20 feet long and 5 feet tall at the hip. These creatures were covered in feathers. This is why fully grown animals look like gigantic turkeys. The Utah raptor's main weakness was their size. They were a bit smaller than many other dinos, but these guys made up for that by hunting in packs. Allosaurus, which means a different lizard in Greek, was a massive carnivore reaching 40 feet in length and weighing 2 tons. It roamed the Earth around 150 million years ago. Similar to T-Rex, this dino had strong back legs and a large snout. Its mouth was full of sharp teeth. The animal easily lost them when eating, but they usually grew back. Allosaurus was already fully grown by the age of 15, and its lifespan was around 28 years. The creature had a short neck and a long, narrow skull, disproportionately big compared to the rest of its body. This dino also had a pair of horns above its eyes and ridges along the top of its nasal bones leading to those horns. Allosaurus chased big herbivore dinosaurs. When several Allosauruses gathered in a group, they could take down even such colossal creatures as Apatosaurus. But scientists still doubt if they could cooperate, because these dinos were generally not too friendly toward one another. Some of the animal's bones had an hourglass shape, which made them lighter and reduced their strength. They were similar to the hollow bones modern birds have. Another weakness of this dino was its bite. It was less powerful than that of some modern animals, like lions, alligators, or leopards. Scientists think Allosaurus may have used its skull as a hatchet. The Therizinosaurus was one of the freakiest dinos out there. It lived 100 to 60 million years ago. It had a very small head and bizarre feet with 4 toes, unlike their ancestors that had 3. Its body was covered with feathers. This weirdo had the longest claws scientists have ever recorded. They were 3 feet long each. These claws were curved and sharp. The dino used them to collect plants for lunch. Scientists are still not sure if this creature was a herbivore or carnivore, or both. The dino had a long neck. There were no teeth in its upper jaw. Its wrist bones were like the ones modern birds have. The Therizinosaurus might have evolved from a meat-eating to plant-eating animal throughout time. Unfortunately, in comparison with meat-eaters, herbivore dinosaurs were much weaker, and still, those claws could make its enemies think twice. High-spined lizard, or a Crocanthosaurus, lived 110 million years ago. It was 2 feet shorter than T-Rex but had a similar body structure. Like T-Rex's, these creatures often went after bigger and more challenging animals. For example, with those backbones so hard, it seemed as if they were carrying a giant turtle shell, like Ankylosaur. The high-spined lizard was very territorial. It had a brain shaped like the letter S and an excellent sense of smell. What made a Crocanthosaurus vulnerable was its small arms. And still, the creature used them to hunt other animals surprisingly well. The dino pulled its catch close to its torso, which was like a hug you wouldn't be able to escape from. Diplodocus lived 150 million years ago. The 90-foot-long creature was possibly the longest dinosaur ever. Its tail, which could reach 46 feet in length, was the longest tail of any animal ever. And its neck was more than 20 feet long. The underside of the dino's tail had 2 rows of bones, which made the creature even stronger and more mobile. Diplodocus didn't look scary, long-necked, gentle, peacefully munching on plants, until it used its tail like a whip, making even the scariest meat-eaters back away. This tail was the center of the dino's mass, which was why Diplodocus could move very quickly. Scientists first thought, this is a lizard-like animal, but its posture was more like that of an elephant. Plus, Diplodocus had nasal openings on its forehead. The dino's weakness was its small teeth and weak force bite. Quetzalcoatlus was the biggest flying animal ever. It lived 70 million years ago and controlled the skies of North America. It was a toothy, pin-headed creature with a blunt snout. It was as tall as a giraffe and weighed 550 pounds. Quetzalcoatlus had a small torso and long neck and legs. Its wings were short compared to the rest of its body, but still long enough to stretch for 40 feet. Scientists think this animal could fly at a speed of up to 80 miles per hour and travel 400 miles in a day. This dino was weaker than, let's say, T-Rex or most other carnivores of that time, but it had powerful muscles, which helped the animal rise into the air in the blink of an eye.
They ruled the planet for over 170 million years and then disappeared. History says it was a huge city-sized asteroid that came from space and hit the land of the Yucatan Peninsula around 66 million years ago. It caused terrible environmental changes, debris in the air blocking the sunlight so the plants couldn't survive. Temperatures on Earth's surface plunged. The animals were struggling to survive until they finally went extinct. At least, that's something many paleontologists believe happened. Now, they found out dinosaurs were about to go extinct even before the asteroid. Their diversity started to go down 10 million years before the asteroid. Older, long-living species didn't evolve enough to adapt to all changes in the environment, such as higher sea levels, massive volcanic activity, cooler periods. Dinosaurs preferred a warm climate because it helped them to keep a stable body temperature. Dinosaurs lived on all 7 continents, even in Antarctica. That's because it wasn't all ice back then. Around 90 million years ago, Antarctica was a swampy rainforest with a warm, pleasant climate. It was even in a different location, only 560 miles from the then South Pole. That was the time of the warmest climate on our planet. The sea level was 560 feet higher than today, and the tropical sea surface could reach temperatures up to 95 degrees. Antarctica still had something like polar night, months without sunlight, but the climate around the South Pole was mild and temperate, with no ice masses. Dinosaurs didn't shed their skin in one long piece like today's reptiles do. Scientists believe they shed it in small pieces, had something like dinosaur fur. There was a dinosaur, Pegomastax, that looked like a cross between a porcupine and a parrot. It had 1-inch long jaws and ate plants. It had a short beak and self-sharpening long teeth. They were like scissors this small dinosaur used to slice up plants. Our modern lion has a mighty bite, but a big and scary T-Rex bites more than 2 times stronger. The king of the dinosaurs has the strongest bite amongst all land animals, 3.5 times stronger than today's record holder, the Australian saltwater crocodile. It also had the longest teeth, almost 10 inches long, the length of an iPad. Most modern animals are either warm-blooded or cold-blooded. Dinosaurs were somewhere in between. Scientists think they mainly were mesotherms, which means the activity of their muscles could warm their bodies, but their body temperature could fluctuate too. Many dinosaurs, such as Triceratops and Stegosaurus, had spikes, plates, horns, crests, or other bizarre structures on their bodies. In the beginning, scientists thought that's for things like defense. They had neither sharp teeth nor hooked claws on the toes to hunt. But soon, they expanded the theory. It was probably a way to impress their mates and identify members of their kind. One species, namely Pachycephalosaurus, even had a funky bone hat on top of its head. Scary, tall as buildings, massive. That's what we saw in the movies, but dinosaurs mainly were human-sized or even smaller. Bigger bones were easy to be fossilized, so that's why we mostly find gigantic species. Eoraptor, or dawn stealer, was the first named dinosaur. Small and toothy, like me, it got its name because it comes from the dawn of the dinosaur age, the size of a German shepherd, but probably not that friendly. Arched back, sharp bony plates, curved tail. Ankylosaurus were some sort of giant, muck-spikier dinosaur version of an armadillo. Its weak spot was a soft underbelly, but meat-eating dinos that were after this one had to flip that guy first to get there. Still, it was really tough because of their impressive gear. Scientists believe they even had bony eyelids. Some dinos ate meat, others plants, and some of them could nibble even on pebbles. One dinosaur, called Gallimimus, couldn't physically chew all those plants it ate, so it would ingest pebbles to mash up the food. Gallimimus looked like some weird alien mix of dinosaur and bird. But it couldn't dribble a basketball because its wrists weren't capable of keeping the palms parallel to the floor. And they had no three-point shot. The largest dinos were plant eaters. Meat eaters, or so-called theropods, were mostly smaller. One reason is that plant-eating dinosaurs were very greedy. They would devour enormous amounts of food, sometimes even swallowing the entire branches without chewing. Some of the biggest could eat a ton of food every day, like a bus-sized pile. There were also more plant-eating dinosaurs than the other ones. Scientists are still not sure if meat-eating dinosaurs were able to coordinate themselves in hunting groups. They were probably unfriendly towards each other, especially when it comes to sharing prey. Fossils, and the shape of delicate bones in the eye, tell dinosaurs mostly roamed around during the day. Scientists think only smaller meat-eating dinos, like Velociraptor, were active during the night. They were after those small mammals snuffling around and trying to find food while big dinosaurs were asleep, or that's what they thought. Those small mammals were usually burrowing animals that survived both dinosaur reign and ice age hiding underground. Not all mammals were hiding from dinosaurs. Some small but sneaky creatures, like Reptile, would steal the eggs from big dinosaurs, which was a big thing considering they had to trick the mama dinosaur first. Researchers believe dinos tried to flap on the ground to get faster at running up inclined terrains to catch their prey. Such behavior caused them to learn how to fly, which of course happened through thousands of years. Dinosaurs were fuzzy and fluffy. They are related to birds, but even those early dino species that didn't fly had feathers, like gigantic, scary, fuzzy T-Rex. Movies lied. You just can't stand still and expect a T-Rex would pass you by. Its vision was probably better than one today's raptors have. Even without it, they still had a pretty good sense of smell. Running could help it though. Scientists calculate T-Rex could probably run at 12 miles per hour. It would shatter its bones at a greater speed. Some dinos had tails more than 45 feet long. Tails helped them to keep their balance when running, especially those that walked on two legs. Velociraptors were not like raptors we see on the screen, but more like some sort of prehistoric chickens. Small, a little bit bigger than a turkey, 2 feet in height, probably had feathers, hollow bones just like birds, mostly loners. But they were probably among the smartest dinos. Their brain was big compared to their bodies. They were as intelligent as today's ostriches. The name Velociraptor means speedy thief. Stegosaurus had a pretty big body, spiky plates, and a tiny brain, the size of a walnut or lime. But at least it had its own air conditioner. Researchers found out its spikes were filled with veins that transferred blood and developed a theory that they were cooling its giant body that way. Dimorphodon was the flying reptile with a wingspan of 8 feet and multi-purpose teeth. Teeth in the upper jaw were longer, sharper, and better for catching food from the water. The teeth in the bottom jaw were better for holding the game in transit. One of the first potential dinosaur discoveries was in China 3,500 years ago. No one knew about dinosaurs then, so people thought teeth they found could belong to dragons. The Hadrosaurus was a duck-billed dino with more than 1,000 teeth. When they would fall off, it could grow new ones indefinitely. Dinosaurs' eggs were pretty big, some as big as beach balls. Now that's an anomaly. The Baryonyx was a big fan of fish. Its name means a heavy claw, and it got it because of big extended claws that were pretty sharp and made up the thumb of each hand. When catching fish, they used the claws like spears. Mosasaurus, also popular in movies, was not quite the dinosaur but a marine lizard, closely related to monitor lizards and snakes. Like a snake, it had jaws that could expand when swallowing the food. These creatures were speedy. They had a tail fin and flipper-like paddles instead of arms and legs. Researchers believe they had a weak sense of smell and poor perception of depth, so they had to develop a unique hunting technique, waiting for their snack to come up to the surface for some air.
You're picking some veggies in the garden when you come across something big and round. It's covered in soil. When you dig it out, you find out it's a giant egg, bigger than one of an ostrich. But you don't have any chickens or ducks. And even if you did, none of those animals could lay an egg of that size. You pick it up. It seems real. You take the egg inside and build an incubator for it. A couple of days pass, but nothing. You go on with your life and forget about the egg's existence. You've been working in your garden all day long. All you want now is to get into a tub filled with hot water and have some dinner later. But while you're eating, you hear some noise coming out of the room with the incubator. You ignore it, thinking it's just some mice scampering around. But then the sound intensifies. You head there and see the eggshell cracking. In a couple of minutes, something begins to crawl out. You grab your phone and immediately start filming it. A tiny reptile pokes out of the now broken egg and starts examining its surroundings. You're shocked. You place your phone on a special platform to keep filming the creature. Meanwhile, you grab your laptop and begin researching what animal it could be. The creature doesn't have the snout of an alligator, nor does it look like a Komodo dragon. You go back to your dinner and feed the reptile some leftover meatloaf. It gulps the food down in a flash. The next day, you build a small terrarium to keep an eye on your new pet. Over the following weeks, you record every second of its life. You call the reptile Buster. The creature has already grown to the size of a dog. It runs fast and jumps pretty high too. You think it might be some new reptile species, but it doesn't crawl like an alligator or a lizard. Your pet has 2 tiny arms and large legs. Its jaws are massive for an animal its size. The reptile also has razor-sharp teeth. Your friend comes over for a movie. At one point, your reptile runs into the living room and starts biting the furniture. Your friend freaks out and starts yelling, "Dinosaur!" You calm him down and take the dino to the garage. You explain to your friend how you found the animal, and he tells you to contact someone to examine it. The next day, you take Buster to the vet and take a seat in the waiting room. You keep your pet in a cage so that no one can see it. But the dino starts growling in a strange way. Many people grab their pets and move away from you. It's finally your turn. You bring Buster in and show it to the veterinarian. The man looks shocked. He puts the creature on a metal examination table and starts looking closely at its features. Sharp teeth and claws, scaly skin. The vet tells you you've been raising a T-Rex for 3 weeks. He calls in other specialists to examine the animal. The next thing you know, you're in a lab with a bunch of scientists studying Buster. You sit there anxiously as they collect its DNA samples. They even ask for the footage you've been recording. After a couple of hours, they come back and tell you that you indeed have a dinosaur. They'll have to keep Buster in the lab to conduct further studies. So you go home, feeling a bit lonely. A couple of years pass. Now you have a degree in paleontology, specializing in T-Rexes. You've been working with the lab and monitoring Buster that has turned into a fully grown dino. You also teach at the university and have published a book called My T-Rex Buster. It has become a bestseller. One day, you come back from the university and turn on the TV. That's when you hear breaking news. A large creature has broken out of a lab outside the city. It's now on the loose. They show several images of the beast's footprints that lead to the forest. You get a call from the lab. They ask you to head down there as fast as you can. The researchers tell you what's happened and ask you to accompany them to the forest to find the dino. You put on a special protective suit and get into a jeep. After a couple of hours, you arrive at the spot where Buster was last seen. You get out and try to follow its footprints, but the rain has removed the marks the creature left almost completely. The scientists check the tracking device placed under the dino's skin, but it's not working. They bring some food Buster likes to try to lure it out. After a couple of hours, there's no news. It's already night when you hear some rumbling in the distance. Everyone jolts awake. People around you are on high alert. You hide and wait. A large shadow the size of a school bus appears from the dark. A fully grown T-Rex can reach 40 feet long and 12 feet high. The giant lizard approaches the meat and sniffs it. After a couple of moments, it runs off. Everyone gets out of their hiding places and tries to follow the animal. The meat has a special substance in it. It was supposed to put the dino to sleep. This way, it wouldn't be a problem to bring it back to the lab. But the dino was smart enough to feel something suspicious. Despite its size, the T-Rex is quite slow. It can move at a speed of only 12 miles per hour and can't even outrun a human. But Buster somehow manages to cross a raging river and disappears into the dark forest. No one has been prepared to make it through such an obstacle, so the whole team makes a detour through the mountains. It's a difficult climb, with everyone carrying the equipment needed to catch the T-Rex. From the height of the mountain, you can see almost all the forest. Far away, treetops are shaking. The giant reptile is heading to the north. Everyone tries to get to the other side of the mountain as fast as they can. But then, one of the crew members slips and falls. Good thing a safety rope holds her in place. You pull the woman back to the path. You continue walking until you reach a cave. Everyone puts on their helmets with flashlights and goes inside. The deeper you go into the cave, the smaller it gets, so you have to crawl to get through. The rocks are sharp, and there's water everywhere. It's easy to get lost in here. The cave starts trembling. Everyone rushes to get through the narrowest part. You finally make it out of the cave. That's when you find out that the cave was trembling because of the T-Rex. It was stomping around the mountain. It spots your group and starts running towards you. People panic and rush back into the cave. The T-Rex catches up with your team and tries to snatch someone, but by that moment, everyone is already safely tucked inside the cave. Suddenly you scream, "Buster!" Shockingly, it seems to calm the creature down. You step outside, even though everyone is trying to hold you back. You get outside and face the massive creature. It's just staring at you. You slowly approach it, trying not to make any sudden moves. Someone from inside the cave gasps. It startles Buster. It starts thrashing and roaring, but you're still there, trying to calm the animal down. Eventually, it gets quieter and comes closer. You put your hand on its head, caressing it. After a few seconds, someone inside the cave steps on a twig and it cracks. The T-Rex jolts and runs away. You're furious. Now, you have to track it once again. After you spend many more hours in the forest, the sun starts to rise. Everyone is exhausted and about to pass out. You decide to call it a day and head back home. But as soon as your team gathers near the jeeps, you receive a notification that a giant T-Rex has entered the city. A helicopter picks up you and the other team members. There isn't enough room for everyone, so several people stay behind, waiting for the next chopper. The T-Rex is dashing through traffic. People in the streets are running for their lives. Dozens of news companies are filming the incident. Many people are posting it on social media. The dino breaks into the mall and destroys everything it sees. Your helicopter lands, and you get out, trying to think of a way to calm the creature down. You rush into the mall, but the T-Rex has already run away to the other side of the building and managed to escape. You're following it, but suddenly you get a phone call saying that the team members left behind in the forest have spotted your T-Rex. You can even see the live footage of the animal. That means there are 2 giant reptiles on the loose in your state.
From tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub impactor now holds first place among the brightest objects in the sky. The light surrounding it, called the halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They in turn generate tsunami waves as high as the Empire State Building. 5 minutes after the impact. The meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface nonstop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon, they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ram. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion, or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth. Hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory. Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash, a massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami, with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs like Triceratops had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash. 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made phytoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of phytoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1 million years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. This hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much later came the iPhone. Alright, check this out. Water boils faster when you add a bit of salt. Myth. It doesn't make any difference, and even if it does, it may take longer for the water to boil. But it might make your pasta taste better. Just saying. Bats are blind. Not true. The myth probably comes from the fact that they're nocturnal creatures and have extraordinary hearing abilities. They chase mostly when it's dark and rely on a thing called echolocation, but it doesn't mean they're blind. Their eyes aren't useless, they're just adjusted to low light conditions. A blue whale is so big, its tongue can weigh as much as a big elephant. True. Yep, these fellas are huge. You lose more heat through your head. Nah. The real reason why people believe it is because when it's cold, our head is the only part we're most likely to keep uncovered. If we went outside wearing just a t-shirt, we'd lose heat through our arms, not to mention legs, hips, and other parts. So, wear a hat, guys. Tongue Map says we have different parts for different tastes. Not really. There are individual taste buds that sense certain flavors more than they do with others, but it doesn't mean one area can taste sweet better than the other. Studies showed all mouth areas have taste buds sensitive to all tastes. Hey, check out this tongue map for the blue whale. Looks like she's partial to plankton. Dinosaurs were giant. Well, that's false. Movies show them as huge scaly lizards, but nope. First off, there were many smaller dinosaur species, and some of them were as small as a turkey or a pigeon. Plus, some dinos, like T-Rex, were even covered with feathers, especially at the early stages of their lives. Oxygen is colorless. Partially true. In gas form it has no color, but in solid or liquid form it has a sky blue shade. Chameleons change color because they want to match their surroundings. Myth. That would probably be a very tiring thing to do. In reality, some other things like mood, temperature, or the amount of light they get affect their color. When chameleons relax and stretch cells, crystals that are inside of them are affected by the light. These animals use crystals to communicate with each other. So, for example, darker shades show that they're not in such a good mood. It's more like they kind of feel aggressive. So I think I'll back off here. Neanderthals aren't our ancestors either, even though they lived with modern humans at the same time at one point, but mostly in different areas of our planet. So they're not just a stage of human development, but a different lineage. They were also pretty creative. They used fire, made tools, ate medicinal plants, cleaned their teeth, and so many more things similar to our species. Neanderthals probably went extinct because of harsh climate changes. Turkeys can blush. That one is true. They're just like us when it comes to this. When angry, excited, or even feeling bad, the skin on their necks and heads turns red, just like my big brother. Black holes are not really holes, as the name may imply. They are very dense objects with an extremely strong gravitational pull. Flamingos are such cool animals. True. They bend their legs at the knee. Myth. They actually bend them at the ankles, since the knees are closer to the body as well as covered in feathers. Supermarket apples are fresh. Maybe yes, but maybe not. They can be up to 1 year old, since they're often picked between August and November. After that, they're covered in wax and dried in hot air. Finally, they're sent into cold storage, and after 6 to 12 months, we see them on the supermarket shelves. Bottled water has an expiration date? True. But that doesn't mean the water is the thing that expires. The bottle does. The plastic starts to leak into the water and some unwanted chemicals appear. The tea bag wasn't actually planned. True. In the early 20th century, Thomas Sullivan filled small silken bags with samples of tea leaves and sent them to his customers. The idea was to open them and toss tea leaves in the hot water. Many customers thought they were supposed to put those bags into the teapot without opening them. The tea bag went through some improvements, got string and a paper tag at the end, and the new unplanned invention was ready. Lightning will never strike the same spot twice. Not true. The Empire State Building was once struck 8 times in only 24 minutes. There was a terrible storm, and nothing could or can generally keep lightning away from the place that got hit. If a struck place has features that attracted the lightning in the first place, like terrain shape, standing water, or height, it may attract it once again. You have so much DNA in your body that you can actually stretch it from the sun to Pluto and back. True. And not just once, 17 times. Of course, you're not going to look the same after you do that. Crocodiles are one of the oldest species in the world. Yup. They have been around for 200 million years already. Like my neighbors down the street. Opossums sleep while hanging by their tails. You can see that in cartoons and some photos, but in general, they don't. Their tails are really strong, so these animals can grip branches and hold their weight, but only for short periods. Adults are really too heavy to stay in this position for too long, so they wouldn't get much rest. Goldfish have a 3-second-long memory. Nope. Those colorful fish are actually really smart. One study showed goldfish could tell the difference between 2 classical songs. They're not quick learners, true, but after over 100 sessions, they did it, which wouldn't be possible if their memory could really last only for 3 seconds. One type of salamander, you can read that on your own, go ahead, can extend its tongue over half of its body length in only 7 milliseconds. True. That's 50 times faster than a blink of an eye. Ooh, gotta be fast to catch that tongue map. People can multitask. Not true. Checking emails, talking on the phone, cooking, it seems like doing several things at the same time saves time, but research shows multitasking is not quite possible. Our brain is wired to do one thing at a time. So when we think we're multitasking, it's actually switching tasks, which can take even longer rather than saving us some time, as well as whittling down our attention spans. Earth is not the only planet with water. NASA discovered Jupiter had an ocean with twice as much water as we have on our planet. It's right under a layer of ice. Even Mars has some liquid water flowing. Also, the Earth is round. Or is it? Technically, it has flattened poles, together with a bulge at the equator. That way, it has an irregular shape of an ellipsoid. Zombies are not made up. True. Okay, humans can't turn into ones as we see in movies, but the animal kingdom has its zombies. For instance, there's a type of fungus that takes over ants, spreading specific chemicals in their brains. That makes an ant leave its family looking for the place where this fungus wants to live. The world's biggest waterfall is under the ocean. Oh, very true. It's in the Nordic seas. The cold seawater is denser than the warm waterfall. The drop is almost 2 miles long. The smallest wasp in the world is not bigger than an amoeba. True. This wasp has the same body parts as other bugs, like eyes, wings, brain, legs, and more, but it's just 0.008 inches long, which, in most cases, makes it smaller than one-celled organisms we also know as amoebas. Snow can only be white. Not true. And I'm not talking about the snow near fire hydrants. For example, there are some mountains with pink snow, like the Sierra Nevada in California. Its color is caused by a certain type of algae living there. Aurora borealis has a sister. True. It's called Aurora australis, and you can see it in the southern hemisphere. The best time to see it is in winter. Over 99% of atoms is empty space. True. If we collected all the people in the world together and removed all the empty space between the atoms out of them, the population of Earth would fit into the size of an average orange. I think we should try that. Then I could finally get a seat on the bus. Dolphins communicate and call each other by names. True. They use specific vocal whistles to identify each other. So long, and thanks for all the fish. The toilet flushes in different directions when on different hemispheres. Nope. The direction is the same whether the toilet is in Australia or France. Really? A snail can have a pretty extended nap. True. Some snails can sleep for around 3 years in a row. Sharks smell just one tiny drop of blood from miles away. Not quite. Sure, their brain region in charge of smelling odors is enlarged, but the ocean is really big. Plus, it takes time for odor molecules to spread in liquid. On a pretty good day with favorable currents, a shark may smell the prey from a distance of a couple of football fields away, but not miles. Finally, penguins propose to their significant other. True. They're monogamous, and after choosing a mate, the male gives the female a pebble to show his affection. Ah. So your starship is flying through space at 99.9% of the speed of light. Hey, aren't you cool? The stars turn into bright, continuous lines. Infinite outer space has shrunk into a tunnel. A bright flash ahead. Boom! Starship shoots out of the tunnel like a cork. You see the ancient Earth. The computer says you went back 70 million years. You're a paleontologist of the future who traveled through time for one purpose – to see with your own eyes the most underappreciated dinosaur in history. You have come down to Earth and are walking through the jungle. Suddenly, you hear a mighty roar. There's a dinosaur coming out of the trees. It's more than twice your height and weighs as much as 4 cars. Scientists have found only 2 huge arms left of this dino. For 60 years, Dinocheirus has been a major mystery in paleontology. Now we can see this creature in its entirety. They managed to find a complete set of fossils in Mongolia. Translated from Latin, the name of this dinosaur means terrible hand. Apparently, this dino was lousy at playing poker. Dinocheirus is an animal cocktail that nature is prepared to make you both shriek and laugh. Let's take a look at it from the point of view of the evolution itself. First, we take the T-Rex. Dinocheirus and the king of the dinosaurs are about the same size. From the T-Rex, we'll only leave the powerful hind legs and the long tail. Instead of small forelimbs, we'll attach mighty 8-feet-long arms. And let's not forget about the fingers with razor-sharp claws. Each claw is as long as a kitchen knife. Then we add a hump like a camel's, a neck like an ostrich's, and a horse's head. And instead of a toothy mouth, we put a duckbill. Now our Dinocheirus is ready. It also has long and sharp claws on its flat feet. Such broad soles help it walk along the river bottom and not sink into the silt. Most scientists believe it was covered in feathers too. Plants were the main dish on this dinosaur's menu. To digest plant food, Dinocheirus swallowed stones. Many modern birds do the same. Stones in the stomach grind the tough plant fibers. In one of the Dinocheiruses, scientists found 1,400 of those. Yes, this dino had a huge belly, which slowed it down a lot. With such a size, Dinocheirus lived for a very long time, 75 to 300 years, give or take. In a 100-million-year-old piece of amber, they found strange bones. They belong to the smallest dinosaur known to science. Take 2 paper bills from your wallet. This dino weighed the same. It was about the size of a modern hummingbird. Scientists don't know what the tiny dinosaur looked like more, a lizard or a bird, but they're pretty sure it could fly and hunted insects. Over 100 sharp teeth confirm that. What happens when you cross a chicken and a crocodile? You get one of these bad guys, a Hesperonychus. This dinosaur was small but had quite an attitude. It lived in North America and probably hunted mammals. It weighed only 4 pounds and was covered in feathers like a chicken. If the sloth was a dinosaur, it would look like a Suzhou lizard. It moved on 2 legs, was as tall as a modern giraffe, but weighed 3 times as much. Suzhou lizard had feathers on its body, and a long neck helped it look in all directions. Overall, the tail of this dinosaur made it look like a giant rat on two legs. When scientists first saw the fossils of this animal, they didn't believe they were real. The Hultskoraptor looks like a hybrid of a velociraptor and an ostrich, only this dino was the size of a goose. The creature's strong hind limbs confirmed that it could walk on land. The dinosaur hunted fish, diving underwater for its prey. Now, we're used to flying animals having two wings, but evolution loves to break the rules. The Microraptor had 4 wings. Strong feathers were attached to each of those. The dinosaur weighed no more than 2 pounds. Its feathers were black and shiny like a crow's. There are no birds on the planet that have 4 wings. That means they evolved from 2-winged dinosaurs. Microraptor was the dead-end branch of evolution that didn't give way to any new species of animals. It seems that this hard-to-pronounce guy, I'll give it a shot, Tanystrophus, was a dinosaur drawn for a cartoon. But it existed in reality and lived in the water. It weighed 300 pounds and was 20 feet long. Half of its body was a flexible neck the size of a green anaconda. Scientists don't know why the creature had such a long neck. Most likely the dinosaur used it to catch fish or play jump rope. Imagine that 66 million years ago, I wasn't around then, an asteroid didn't crash into our planet. The dinosaurs didn't disappear, and the mammals failed to dominate the Earth. This means the primates didn't evolve and remained in the trees. Who would have taken the place of primates in such a world? Many scientists believe it could be Troodon. The dinosaur had the largest brain relative to body size. It walked on 2 legs and was about the size of a human. Hypothetically, Troodon could evolve and become as intelligent as we humans are now. By the way, the smallest brain relative to body size belongs to Stegosaurus. It was the largest of the armored dinos. It was a plant eater, but its powerful tail and sharp spikes were feared by all hunters of the age. A Stegosaurus weighed almost 4 tons, but its brain was meh, not much larger than a hot dog. Pagomastax was no bigger than a domestic cat, and it ran wild and free in Africa 100 to 200 million years ago. Imagine a bipedal lizard that looks like a parrot. Pagomastax was covered both with feathers and porcupine-like quills. It had a beak, but 2 sharp fangs grew from the lower jaw. Still, the creature's scary appearance is deceiving. The dino ran fast and could bite hard, but it was a peaceful plant eater all the same. Now, this one, Linhenicus, lived 80 million years ago. It resembled an ostrich that weighed like a medium-sized parrot. It could run quickly and hunted insects. Instead of arms, this dinosaur grew 2 tiny fingers with claws on their ends. It's the only one-fingered dinosaur known to science. This strange creature was one of the ancestors of modern birds. Jeholopterus was a flying dinosaur, looking as if it came straight from a sci-fi movie. It looked like a cat with bat wings. The creature was feeding on insects, but there's another theory that it could feed like a mosquito. This dino landed on the backs of large dinosaurs and pierced their thick skin with sharp fangs. Now, this is a fairy tale unicorn. It's as white as snow, beautiful and graceful. And this is a Qingdao lizard, the real-life prototype of that horned horse. A bony horn more than 15 inches long grew on its head. Perhaps the horn helped float in the water, attract partners, or make different sounds. The fairy tale unicorn is definitely cuter than this prehistoric creature. Our next guy, Inostrancevia, resembled a cross between a lizard and a tiger. Imagine an animal that weighs as much as 5 wild boars, with the body length of a sedan. Limbs with sharp claws, fangs similar to those of a saber-toothed tiger, and powerful jaws. It was one of the most dangerous animals that roamed the planet Earth. It occupied a niche that today belongs to lions, tigers, and other large cats. Next, please. Epidexeturus. Now, this is a small dinosaur about the size of a pigeon. It couldn't fly, but it was one of the first dinos with feathers. They were different from those of modern birds, though. They weren't divided into separate threads, but were whole and resembled plant leaves. This big guy, Therizinosaurus, isn't only known for its strange appearance and size, although it was as tall as a 5-story building and weighed like an elephant. The giant was notorious for the largest claws on the planet. It was really a manicurist's nightmare. 2-inch-long scythes protruded from its fingers. Despite those horrific appendages, it ate plant food, chewing it with its small teeth. The humongous jaws were needed to pull leaves off of tall trees. Ouch! Hey, I'm growing here! Meet the largest animal that flew in the earthly sky, Quetzalcoatlus. Just imagine a creature with a wingspan almost the width of a basketball court. To lift such a machine, it needed to be lightweight, so it only weighed as much as a modern pig, with its wings looking like a thin membrane. They stretched from the bottom of the legs to the elongated fingers. Artists often depict this creature covered in feathers, but its body was actually coated with fibers similar to human and animal hair. Acrotholus is an unusual dinosaur that wore a cap made of hard bone. No, not a baseball cap. The creature was the size of a Labrador retriever dog, but not as friendly. It wouldn't run after a stick. Rather, it would rush and ram its hard head into the rival of the same species or a predator. Hello and welcome to the fight of the century. Today in our ring is Tyrannosaurus rex, the king of all dinosaurs that lived on Earth about 70 million years ago. T-Rex was one of the largest terrestrial predators ever existed. Even its name, Rex, means a king. And a round of applause for its opponent, Spinosaurus, a large lizard-like dinosaur that's 20 million years older than T-Rex. It can be recognized by the sail on its back. With its help, Spinosaurus could scare away predators and appear even larger than it actually was. And with that sail and tail, it was one of the few dinosaurs that could swim. We'll have 5 rounds plus a bonus round. The challengers will get 1 point for each round, and then they will step into the ring for a final battle. The first round is size. The biggest individual of T-Rexes was Scotty. Its legs alone were taller than a basketball hoop. And if T-Rex straightened its back, it would be taller than a 4-story building, bigger than the tallest diving board at the Olympics. It's the height of almost 7 adults. Its feet left footprints on the ground the size of a large dog. And although its forelimbs were only 3.5 feet long, T-Rex remained the most dangerous dinosaur of its time. Spinosaurus walked and ran, leaning toward the ground. It was longer than a school bus. Its skull was one of the largest of any dinosaur that ever existed, and looked like the skull of a modern crocodile. It was up to 5 feet long. Spinosaurus had a sail on its back the size of an adult human. Its hind legs were much smaller than those of T-Rex, and were only 25% of the length of the entire Spinosaurus body. Its tail was elongated and more massive than that of T-Rex because of the tilted gait. The long tail at the back had to balance the heavy body in front. So, Spinosaurus was bigger than T-Rex, and the first point goes to it. 1-0. Moving on to the next category. Wait, no, I mean how heavy. If we put T-Rex on one scale, we would need at least 4 big SUVs to balance it out. 14 tons. The heaviest land animal is the African elephant, but it loses to the ancient dinosaur twice. But for its bones, the weight could have been even greater. They were hollow, so T-Rex could stay fast and agile. Otherwise, it would be almost twice as heavy and way slower. When Spinosaurus ran after its prey, it caused a small earthquake. Its weight was 1 SUV more than T-Rex's, about 18 tons in total. And just like T-Rex, Spinosaurus had hollow bones, but it was still heavier than a large cargo helicopter. So in this round, Spinosaurus wins again, and the score is now 2-0. And the next round is agility. Spinosaurus's top speed was about 21 miles per hour. In general, modern dogs can run at this speed. The fastest man in the world, Usain Bolt, can reach speeds of 27 miles per hour. So, Spinosaurus could catch up with him over a long distance. But Spinosaurus was also one of the few dinosaurs that could swim. This gave it the ability to eat fish and the ancestors of modern stingrays. And if Spinosaurus was cornered by other predators, it could always escape and hide in the water. At the same time, T-Rex could only walk on the water as deep as its legs would allow. Scientists argue how fast T-Rex could run. Some say it was 11 miles per hour. In that case, Usain Bolt could easily run away from it. Another estimate is 45 miles per hour. At that speed, T-Rex could get from New York to Philadelphia in about 2 hours. It was as fast as a modern car. If you met a T-Rex in a safari jeep, chances are you wouldn't escape from it. Also, T-Rex was very maneuverable. It used its tail to keep its balance, and by turning its tail, it could turn and change direction very quickly. For that speed and agility, T-Rex gets its first score, 2-1, in favor of Spinosaurus. And we move on. Strategy. The strategy of Spinosaurus is hard to determine because of the variety of its food. It's somewhat similar to grizzly bears. Spinosaurus mostly fed on fish, and it got its food by grabbing small fish, rays, and other marine animals. Scientists claim Spinosaurus was highly intelligent because it would often eat things it was unable to get on its own. Yes, these dinos waited until some larger predators had finished their meal and feasted on leftovers, something we still do at my house on Tuesday nights. The main tool of Tyrannosaurus was the jaw. It had the power of a crocodile's bite. That means it could easily break even very large bones. And you wouldn't be safe even if you were sitting in a car. That's enough bite force to bend metal. The second technique of T-Rex was ramming. Imagine a big truck coming at you at high speed. Such a battering ram could take down even a brick wall. Besides that, it had powerful limbs and a tail. It used them to knock the opponents off their feet and then hold them motionless on the ground. So T-Rex was a more brutal and capable fighter. It gets a point for that, and the score becomes tied 2-2. And now it's time for the bonus round, the Audience Choice Award. Meanwhile, dinos are having a little break. T-Rex is a true pop culture star. You may have seen it in movies, games, and even memes. Once, T-Rex's face was even on postage stamps. And the world's most famous fossils, of course, it's T-Rex skeleton in the American Museum of Natural History. But such popularity led to many myths about it. T-Rex could see motionless objects. You couldn't get away from it by just standing still. What's more, its eyesight was 13 times better than humans, and its sense of smell was excellent. It could track you like a hound dog. Unlike T-Rex, Spinosaurus is neither a movie nor a museum star. Today, there's no complete skeleton belonging to this dinosaur. Now scientists are looking for Spinosaurus's fossils. So, in the near future, we'll probably find out how epic this guy really was. The bonus round has no effect on the score, so we're still tied 2-2. The last round will decide everything. Combat tools. Spinosaurus used its teeth to get food. They were slightly bigger than your finger and as sharp as a needle. And there were 7 of them at the very tip of the jaw. But they were too short to do any damage to big dinosaurs. The rest of the teeth were deep in the jaw and were used for chewing. Other dinosaurs feared the claws of Spinosaurus. One of his thumbs could be as long as the distance from the tips of your fingers to your elbows. And this thumb ended with a sharp hook-shaped claw. These claws could leave a big mark on the skin of even the biggest dinosaurs. Now, let's look at the fighting tools of Spinosaurus's opponent. We know about the strength of T-Rex's bite, but it could have been even greater if their cone-shaped teeth had been stronger. They were the size of a large banana. This made them extremely sharp at the ends, but their enamel was pretty thin. Another tool were the claws. They were razor sharp and as big as a TV remote control. And its tail was so massive that its blow could knock down even a very large dinosaur. Time to let our fighters back into the ring. During the break, T-Rex chased a small dinosaur and ran out to the coast. Spinosaurus was waiting in the water looking for some snack. T-Rex rushes forward first. It reaches its maximum speed and tries to use its battering ram, but Spinosaurus manages to bounce aside. Agile T-Rex turns around quickly and knocks Spinosaurus off its feet with its massive tail. Then it tries to crush it with its foot. But Spinosaurus begins to swing its limbs around and scratches T-Rex. This gives it time to get on its feet. But in the next second, T-Rex bites it hard. Spinosaurus decides to retreat towards the water. T-Rex chases it until it's up to its neck in the water. It can't chase it any longer because it's not that good at swimming. Spinosaurus doesn't want to continue the fight and swims away to a safer place. And T-Rex wins this fight and takes the title of champion of all land dinosaurs. Are we off? Okay. Whew. Good thing the folks at home can't smell this. These guys stink.
Meganeuropsis was a giant dragonfly that lived on our planet almost 300 million years ago. It was about the size of a modern-day falcon, with a wingspan as long as your leg. It had long and sharp claws that it used to catch food and for protection. They could even grab small animals and carry them through the air. Their speed and maneuverability made them formidable hunters. Meganeuropsis is the most giant insect ever found on Earth. Scientists believe it might have reached this colossal size because there used to be more oxygen in the air. There were other gigantic insects that lived before the dinosaurs too. Some ancient ants could grow to the size of a hummingbird. And if that wasn't scary enough, they could also spit acid, like something out of a movie. These ants lived in large colonies, and their anthills were several times bigger than the ones we see today, and could resemble a bear's den. This thing is an Arthropleura, an ancient ancestor of the giant millipede. This monster dwarfed the last two animals, growing to the length of a car. It lived in rainforests, and it could move at great speed. Imagine being chased by one of these. Fortunately, Arthropleura weren't carnivores like today's centipedes. They only ate plants. Another reason the insects grew so big back then is that there was less direct competition. They could evolve and grow without being eaten by more successful animals. Brontoscorpio lived about 400 million years ago and could reach 3 feet in length. That's 15 times longer than modern scorpions. And unlike modern ones, it had not 2, but 4 claws. This amazing creature could also breathe on land and underwater. That's because it had both gills and lungs. It's believed that these guys were some of the first to evolve and change their habitat from water to land. Now, onto a far stranger marine animal, Anomalocaris. It's thought to be the very first predator to live on our planet. It was half the length of a human, their eyes had color vision, and they were likely the most advanced of any living organism 500 million years ago. They used their sharp claws and mouth parts for hunting trilobites, crabs, and sea scorpions. It's possible that Anomalocaris was what eventually pushed crabs and scorpions onto the land. They might not look very similar, but Anomalocaris was also an ancient ancestor of modern crabs. Dunkleosteus was an enormous ancient fish. These guys were half the length of a school bus and weighed the same as a small car. They had no teeth, but evolved to use the bone plates on their jaws as a replacement, leading to their crazy appearance. This allowed them to have the biting power of a modern Mississippi alligator. Most impressively, it could close its jaw multiple times in less than a second. This created a powerful flow of water right into its mouth. Smaller fish would get caught in the current and pulled right into a Dunkleosteus's mouth. Their skull was heavily protected by bony armor. It was like it was wearing a helmet. This protected it from almost any strikes and made it the apex predator of its time. Achmonistion is the ancestor of all sharks in existence, living around 340 million years ago. No one knows why, but in addition to the usual shark fin, it had something that looked like an anvil on its back. Another feature of the Achmonistion was a massive spike on the underside of its body. It was very sharp and covered with many teeth. Tiktaalik were some of the first animals to set foot on land. It had gills and scales, like a fish, but it also had some of the features of land animals. It looked a bit like a cross between a fish and a lizard. Its front and back fins began to turn into limbs, so it could crawl along shorelines, and it developed lungs as it spent more time out of the water. This weird fish may be the ancestor of pretty much every modern land animal today, including us. Back to land, this is a Dimetrodon. It looks like a lizard, but it's actually a synapsid, a close relative of mammals. It was the size of an alligator and had a giant sail on its back. Scientists aren't certain, but it's believed that the Dimetrodon used this sail to get heat from the environment faster. It also helped them camouflage themselves in the tall grass. These guys are often confused with dinosaurs, but they disappeared 40 million years before the first dinosaurs appeared. Over time, synapsids evolved into full-fledged mammals, and if we go further down this chain, we'll find out that humans evolved from these guys too. Dinocephalians. The name of these guys literally translates to scary-headed. This is because, in the process of evolution, their skulls became much thicker. These creatures were usually 19 feet long and weighed the same as a car. Some of them had long fangs like a saber-toothed tiger, but these giant lizards were herbivores. That doesn't mean that they were completely peaceful and docile, though. Scientists believe they fought within their species. They smashed their heavy foreheads into each other, like rams do now. Dinocephalians existed at a time when all our continents were still connected in a supercontinent, called Pangaea. Gorgonopsia looked a little like Dinocephalians, only these guys were carnivores. They were about the size of a wolf, but they spent a lot of time in water too. They usually lived on coastlines and could dive into the sea looking for food. They were also the first predators that could run fast. This is one reason why Gorgonopsia ruled the world about 265 million years ago. Later, these species mysteriously disappeared, leaving the dinosaurs to dominate the Earth. The cause of the mass extinction about 240 million years ago is unknown, but the second event that caused the extinction of 95% of all living organisms on Earth was a giant meteorite. The oldest tree remains are 385 million years old. Archaeologists found them inside a rock, where there were traces of the roots of many species of trees. These ancient trees evolved and began to turn the carbon dioxide in the air into oxygen. Gradually, they created the atmosphere we have now. This is the oldest winged insect in the world, Rhyniognathus. It's about 400 million years old, and there's still debate about the way it lived. Supposedly, it fed on plants, but it also might have eaten other animals. The oldest species of millipede is Pneumodesmus neumani. It may have been the first living organism to breathe on the barren Earth, around 400 million years ago. This little guy was only as long as a seed, but we only have one fossil, so they might have grown a bit bigger. Pneumodesmus might be a distant relative of all the millipedes and centipedes that exist today. The farther we go back in time, the more bizarre the living organisms look. 480 million years ago, Agirocassus coasted through the ocean. For its time, it was the largest animal on the planet, reaching 6.6 feet in length. Fortunately for other sea creatures, it wasn't a scary hunter. It ate the same way that the blue whale does today, swallowing loads of water so it could catch all the tiny things living in it. Dickinsonia lived 550 million years ago. These floating ovals varied a lot in size. Some could be the size of a fingernail, while other species were as big as a kitchen plate. The largest Dickinsonia may have been as wide as a stingray. These animals are so primitive that they didn't even have a skeleton. Some scientists thought it wasn't even an animal, but a fungus. But that was later disproven. Charnia was another animal that scientists originally thought was a plant. They believed that it was just the leaf of something like a fern. They realized that it was an animal when it was found that Charnia lived deep underwater, where photosynthesis is impossible. These guys swam near the bottom of the sea and fed on nutrients from the water. Instead of a traditional digestive system, these things had filters. They ran water through them to catch food in it, like the Agirocassus. The first living organism is thought to have appeared about 4.2 billion years ago. When the oceans first formed, they were filled with things needed for life to exist. Under high temperatures, this matter began to interact and join together, forming the first living organism. This is why we look for planets with liquid water. We know life on Earth started with water, so many people believe that water is the most important factor in the origin of life.
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66-million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. You know, when someone says dinosaur, a picture of a giant, scary monster mostly pops up in our brain. Even their name means terrible lizard in Greek. Yup, some of them definitely incited fear and trembling whenever they went. But not all dinos that used to walk, fly, or swim were gigantic. Plenty of them weighed less than 130 pounds. Some were the size of today's pigeons. Mouse, fox, deer, giraffe, elephant, whale, modern animals come in different sizes. But out of around 700 known dinosaur species, there's a big gap between gigantic and those smaller ones. No middle-sized dinos documented or found. Big carnivores such as T-Rex ruled the Earth. Smaller dinosaurs could hide when they saw them coming, but middle ones wouldn't stand a chance. Even if they somehow managed to run away, the juveniles of these biggest predators would come after them. These dino teens acted like a species of their own. As they were growing up, they would get their predatory features, but they were still strong enough to catch middle-sized adults of some other dinosaur species. Teenage T-Rex, for instance, was much slenderer than its parents, but also got those fearsome teeth and powerful tail we'd be afraid of at a pretty early age. Yow! Herbivores grew so big because they were, well, quite greedy. These dinosaurs could eat enormous amounts of food in a very short time. Sometimes they would even swallow whole branches so quickly they didn't even have time to chew. Since they didn't have sharp teeth like carnivores, evolution had to give them something else for protection, things like horns and spikes. But also, carnivores were smaller, which is another reason they had carried on for so long and managed to survive. The smallest dinosaur skeleton found was called mouse lizard. Go ahead, try to eat that one, T-Rex. You'd have to find it first. Scientists used to believe birds evolved from meat-eating dinosaurs called theropods. That's the group where T-Rex belongs to. But later, they found birds evolved from smaller species from that group. Whew, we really got lucky there. Dinosaurs mostly hatch from eggs, like birds. Even when they classify dinos, scientists don't divide them into plant or meat eaters. They say there are two groups, one that had lizard-like hips and the other with bird-like hips. The oldest fossilized bird dates back 150 million years. Those birds even kinda looked like smaller feathered dinosaurs. They had sharp teeth, but again, luckily, they lost them and later evolved beaks. Picture if they didn't. Today, toothy pigeons would be chasing us around. Okay, take it easy, buddy. Not so funny anymore. So, speaking of small feathery creatures, T-Rex was also one of them. Yeah, hard to picture it, but even the tyrant lizard king wasn't always that scary. In the early stages, T-Rex was just a fuzzy ball, big as an average-sized turkey. Juveniles were small and weak. Predators, sickness, lack of food, all these things would sometimes be too much to fight after getting out of the egg. So, small, fluffy T-balls only had 40% chance to survive to their first birthday. Bam! The asteroid hit the Earth. The big space rock was the size of Mount Everest, and it traveled at 45,000 miles per hour. After it entered the gravity in Earth's atmosphere, it turned into a fireball. Dinosaurs were spread all over 7 continents, even Antarctica. True, Antarctica wasn't covered in snow those days. Poles had rich forests growing there. Not only dinosaurs went extinct at that point, but around 75% of all animals that lived on Earth. When the asteroid hit, it made a large crater where this huge heat wave and blast wave went out, throwing enormous amounts of matter into the atmosphere. The soot in the air didn't completely block out the sunlight, but it was seriously reduced anyway. Without light, plants didn't have conditions for normal growth. That way, fewer herbivores could survive, which meant less food for carnivores. The whole ecosystem started collapsing like dominoes. Dinosaurs have been gone for the past 65 million years, but their family trees have stretched back 165 million years, way more than the human ones. But not all dinosaur species lived at the same time. Fossils are the only way we ever got a chance to meet dinosaurs. Our age never actually mingled with the era of these magnificent beasts, since some form of humans were only here 6 million years ago. More modern humans that we can closely relate to walked the Earth roughly 200,000 years ago. Some species did see dinosaurs though, like green sea turtles. These fellas have been here for so long, I guess they really have lots of cool stories to share. And not just them. Bees, starfish, lobsters, crocodiles, snakes, sharks, horseshoe crabs, cockroaches, and many others were also there to see the dinosaurs rise and fall. Dinos mostly had pretty small brains, like me. For example, Stegosaurus had the brain the size of a walnut and could grow up to 21 feet. No jokes here, since good old Stegosaurus had some other impressive features, such as those huge upright plates on its back. Yep, those could reach up to 30 inches in length and are something we all recognize this dino for. Scientists are still not quite sure what these plates were for. Perhaps for regulating blood flow and, by that, controlling Stegosaurus's body temperature. The plate system might even control their skin color, which came in handy if they wanted to scare off predators or attract potential mates. Troodon had a bit more than a walnut in its head, a body more than 6 feet long, a brain the size of today's birds or mammals, great hunter, stereoscopic vision. It was also one of the first dinosaurs discovered in North America. T-Rex is the most famous dino, and one of the first ones we think of when someone mentions big lizards. But it wasn't even on the list of the 15 biggest in the whole group. Argentinosaurus was the biggest dinosaur and the biggest land animal ever found. 100 feet long, 75 tons. Wow, this one really made the ground shake. So if dinosaurs were alive in our age, and you were on the 6th floor, casually watching TV and chilling, and suddenly seeing the head peeking in on you through your window, yup, that would be Argentinosaurus. That wouldn't be such a big problem since this giant was a plant eater. So it would probably wait for you to throw out some fruits or vegetables from your fridge. Now, considering its size, you need to have around 1,500 to 2,000 pounds of plants. Phew, triffle, who doesn't have that in the fridge? Plesiosaurus was a marine reptile that lived in the dinosaur era and went extinct almost as they did. I think I'd rather face T-Rex than this one. Dinosaurs ruled the land where you can at least take shelter, I guess. But Plesiosaurus ruled the waters, and you got nowhere to hide there. This giant would propel itself through the water with its enormously strong, paddle-like flippers. They'd move the animal up and down, sort of like birds' wings. So, if we'd give away some titles, this one, Suchosaurus, would be promoted to the weirdo of the dino group. It looked like a huge rat with a very furry body. Its look suggests it could be related to today's ground sloth. For a long time, scientists thought dinosaurs were cold-blooded, like lizards, snakes, and other reptiles. Later on, another research came in, and it turned out they were more of warm-blooded animals, something like mammals. In 2014, scientists finally settled that dinosaurs were mostly mesotherms. That means they were somewhere in between. Scientists observed fossils found in ancient rocks to find out when some animal lived and how it behaved. Most of the fossils found were from dinosaurs that lived near water. Water covers their remains with mud, keeping them buried deep below. Not many fossils have been found in mountains or deep in jungles. Even before dinosaurs, there were some pretty scary reptiles. Ruling lizards, archosaurs, mammal-like reptiles, therapsids, and pelycosaurs. Around 20 million years after dinosaurs appeared and evolved, one of the most dangerous reptiles was still out there, the prehistoric crocodile. A couple of million years more were supposed to go for dinosaurs to truly start their reign. No one ever discovered what kinds of sounds dinosaurs really made. In movies, people mix various sounds some of today's animals produce. For instance, T-Rex had a roar that was a combination of a tiger's snarl, the squealing of a baby elephant, and an alligator's croak. And its breathing was the sound of air going through the whale's blowhole. Same with their color. People mostly think dinosaurs were grayish-green because that's how they show them in movies, as some sort of big lizards. Their color still remains a mystery, but recent research has shown pigments some species had, with one in particular having white and orange rings on its tail. How cool. Ah, that's funny. Well, everything is when you're a giant hyena, Pachyrhinoceros. If you want to picture how animals from ancient times look like, just imagine them way bigger with larger and sharper teeth. And wait, like that isn't enough? Yup, you had to be one mighty beast to survive in such times when everything around you is like 5XL. This hyena was up to 3 feet tall with a weight of 400 pounds. That's the size of a modern lion and around 3 times bigger than today's hyena. The ancient one also had shorter legs, which is also the reason plenty of prehistoric creatures went extinct. Over time, they ran out of food, but couldn't run fast or long enough to catch prey. Also, they couldn't escape quickly enough if there was some bigger guy nearby. Ancient and modern hyenas have quite similar habits. Diet, meat, and meat. They both prefer to steal food from other usually smaller predators rather than go hunting on their own. And of course, they're both always smiling at everyone around. Cheese! You always somehow picture sharks as those marine animals we should be afraid of, right? Not whales. They're mostly good-natured, eating their plankton, spraying out water through that hole in their backs and stuff. And of course, they could get a little clumsy from time to time, so they turn over a ship. Anyway, they're not that into hunting humans. Well, if we all lived in the time of this 50-foot, 50-ton whale, Leviathan, I like to call Toothy, let's just say going to the beach would never be the same. The beast weighed like 6 elephants and was longer than a truck. Oh yeah, about that Toothy thing? This whale had teeth longer than your palm and a quite refined hunting instinct. So it went after all marine animals, including other whales too. Its only rival was the megalodon itself, the only biggest and scariest shark that ever lived on our planet. Okay, of course, this list is full of giant and dangerous animals with extra sharp teeth who you're certainly glad they went extinct. But there's also some close relative to a human ancestor here too. Hello, distant cousin? Paranthropus. So our cousin P had a big brain, well, at least for those times, and good reflexes, which is why they could defend themselves against some bigger and less brainy creatures that were after them. They mostly ate plants, roots, nuts, soft fruits, young leaves, probably insects, and seeds. They were around 5 feet tall and 150 pounds in weight. Not that big compared to other prehistoric mammals, but still big enough to survive those tough times. Way to go, P! The next one is, yes, I'm very happy these things went extinct, prehistoric mammal, Gorgonopsia. They were something between mammals and reptiles with, of course, very, very big 5-inch saber-like teeth, an 18-inch long skull, and the size of a modern bear. At their beginnings, these guys were really small, no bigger than a dog. After a while, evolution did its thing and turned them into the biggest carnivores of their time, which was over 250 million years ago. I wasn't around then. Scientists still don't know if they had clear skin, fur, or scales, but they do know these beasts had rather long legs compared to the rest of their body, which means they could run much faster than many other animals from those times. Andrewsarchus, or Andy, my nickname for it, is everything you would attribute to today's predators, such as tigers, wolves, or hyenas. Only a bit more intimidating version, of course, with extremely sharp teeth. Who would have thought the biggest meat-eating mammal that ever lived is actually a part of the family where pigs, camels, and antelopes came from. It had the size of a modern bison, with a weight of at least half a ton. Andy wasn't that picky with the menu, so it went after most other animals that lived back then, which was around 40 million years ago. It seems ancient times were those where tigers or some other predators were afraid of pigs, unlike today. Yup, step back, Terminator pig, Entelodon, is on its way. Okay, research actually showed they were more like hippos, whales, and its cousin Andy. But this cool nickname has already been given, so we can't go back. Early Terminator pigs were no bigger than today's swines, but they grew to become cow size over time. They also had short snouts, but a couple of million years later, evolution decided that's not scary enough and made their lower and upper jaws much longer. Oh, and they got an even sharper set of canines, a special How to Creep Your Rivals edition. Phew! Finally an ancient mammal we don't have to be afraid of. Well, at least if we're not in its way, because if this giant accidentally stepped on you, squish. But at least its menu consisted of plants, so we would be safe at some point. Let me introduce you to the gentle giant thunder beast, Brontotherium. It had quite a sturdy nasal horn, weighed 3 tons, and was 16 feet in length, which is bigger than a modern rhino. The size, unfortunately, didn't help it much. Andy was always just breathing down its neck, preying at it and its companions. Such a list definitely can't go without the menacing saber-toothed cat. Around 4 feet long, 100 pounds, agile, completely capable of hunting in coordinated packs. But you know cats, they like to brag about the catch they got on their own. That's our Megan, Megatherion. You can find her and her companions all over the world, in Europe, Asia, North America, and Africa. Now, we often think all big cats are into running after their prey, but Megan wasn't built for speed at all, nor did it sprint after her prey like some other cats. No, she preferred to wait for the prey to get closer. She would choose a good spot, climb up some tall tree, hide, and simply chill. After a while, some innocent herbivores would go there to drink some water, and bam! Surprise! Megan's down. Her hunting style is something we see in leopards today. Teeth were her main weapon, so gotta watch out for those big upper canines. Oh, finally a name I can more easily pronounce, so I don't have to come up with my own. The giant short-faced bear. This beast could run up to 40 miles per hour. After it cornered its prey, the bear would rear up to its full height, 13 feet, so the poor animal knew nothing good was about to come. Cave bears usually prefer vegetables, but as far as this short-faced one was concerned, nah, meat is way better. It liked to hunt as well as collect what other predators would leave behind. Also, as far as is known, apparently no one ever asked this short-faced bear, "Hey, why the long face?" Leo, the prehistoric lion, Thylacoleo. Gee, sounds like a pharmaceutical. Anyway, 5 feet long, 200 pounds, insanely strong jaws, sharp teeth, long retractable claws, muscular body. Hey, it's me. No, not really. It also had a surprisingly powerful tail. Leo actually comes from the land down under, where ancestral kangaroos lived, and they also had quite strong tails to balance themselves. Okay, speaking of kangaroos, here's one small surprise: Leo's roots. You would think kangaroos, koala bears, and giant wombats were there just to live a happy life until they became someone's breakfast. But their family somehow raised an animal that looked like a saber-toothed tiger, but with bigger teeth. Yes, Leo, way to go, breaking the stereotypes. Leo was somewhere at the top of the food chain in his times, even though he had one quite strong rival, a giant monitor lizard, Megalania, or even some plus-size crocodile, Quincana. Okay, move guys, this is not a video about reptiles, wait your turn. Prehistoric age, dinosaurs ruled all over the region, making a mess, while other animals shiver in fear and hide from them. Hey, not so fast, dinos! There's Mr. R, Raptinomamus, a mysterious mammal that decided to stand up to the authorities. He showed up 130 million years ago and was a badger-like 3-foot-long animal. Doesn't sound much compared to the T-Rex and bigger dinos, but was way bigger than some of those feathery dinosaurs from the same time. Not only that, he would eat them. We don't know how exactly, but let's just say Mr. R had his own ways. I'm guessing it was for breakfast. Baby T-Rex was adorable. There, I said it. Hard to imagine those two words in the same sentence, but come on, even big bad T-Rex didn't pop out of its shell all big, scary, and fully grown. In its first few months on Earth, baby T was a cute, fluffy, turkey-sized ball of fuzz. It was kind of like a weird-looking bird coming out of an oversized egg. Not enough food, dangerous surroundings, asteroids, Poor baby T's were so helpless and weak, only about half of them made it to their first birthday party. Scientists think their fuzz was there to keep them warm when they were still small and vulnerable. Plus, it helped them camouflage and stay safe. Baby T's didn't have big, sharp teeth yet, so they mostly munched on smaller reptiles and insects. Baby T's grew up pretty fast. They put on up to 6 pounds a day. Hey, I've done that. No, not really, just felt like it. The weirdest fact about them? When they were little, their arms looked totally normal compared to their bodies. But by the time they were full grown, their parents were super famous. Plastered all over t-shirts, that would be a T-Rex t-shirt, movies, and the greatest Halloween costume ever, in my humble opinion. But the T-Rex we know and love didn't really exist. First of all, speed. They weren't really that fast. In the movies, you could never get away from them, even if the path was clear and you were in a pretty decent car. Early predictions were that T-Rexes could run somewhere between 10 and 30 miles an hour, which is whoa. But recent research shows they could only reach around 12 miles per hour. Anything more than that would have shattered their massive bones. So relax. After a couple months of training, even the most dedicated couch potato could get away from the sharp teeth of this guy. And what about our good friend Stegosaurus? It lived around 150 million years ago, so it didn't even get the chance to meet those cute baby T's. They appeared much later. We all recognize this dinosaur. It's the one with those ridiculous upright plates on its back. They were sometimes up to 3 feet tall. You could hide behind one. Scientists still don't really know why they had them, but they think Stegosaurus could have regulated blood flow through them, like a massive bony thermostat. They also believe these dinos could use the same system to control their skin color, depending on whether they wanted to look good or look scary. Sounds impressive, right? Well, at least something about them does, because this poor thing had a brain that weighed just a tiny bit more than a tennis ball and was around the size of a walnut. That's a dog's brain in a hippo's body. Troodon was one of the most brainy dinosaurs. A great all-around fella, excellent hunter, stereoscopic vision, 6 feet long, and a brain that just won't quit. What a catch! Troodon's remains were one of the first dinosaur discoveries in North America. One of the weirdest members of the dinos was definitely, well, let's just call her Sue. If you met her, you'd feel like you're looking at a big turkey rat thing with a super furry body. It might be the long-lost grandma of the modern ground sloth. Its buddy, Pegamastax, definitely wasn't far behind when it comes to racking up the weirdo points. It looked like something between a porcupine and parrot. But don't say that to its face, it had a couple of pointy teeth that could sharpen against one another. The largest and one of the heaviest known dinosaurs was Argentinosaurus. No one ever found a complete skeleton, but this beast must have weighed about 100 tons and was about 130 feet long. Compare it to the biggest animal we have now, the blue whale. It's only 100 feet long. When someone says dinosaur, you probably imagine some big-as-a-building beast that could use a tree as a toothpick. Some of them were gigantic, true, like those long-neck, long-tailed dinos. Those things were as long as an airplane. But many of them were small and lightweight, some of them the size of pigeons. The smallest dinosaur skeleton ever found was a tiny mouse lizard. Some dinosaurs had tails that were more than 45 feet long. That way, it was easier for them to keep their balance when running. But they didn't drag their tail along the ground. Dinosaurs kept pretty active and were quite fast, so they kept their tails in the air most of the time. Even though that naughty asteroid wiped most of them out, a lot of dino DNA stuck around and morphed into animals we know today, like birds. The first time anyone even thought of linking the two together was after they discovered a primitive bird in Germany, sehr gut. Later, researchers classified two groups of dinosaurs, depending on what kind of hips they had. The first group looked pretty familiar. They had lizard-like hips. The second group had bird-like hips. And a third group looked like Shakira, which is where her tune My Hips Don't Lie comes from. Actually, no. Also, plenty of old-school carnivores had bones filled with air, which is something birds have too. Birds may be the dinosaurs' living descendants, but some animals actually witnessed the age of dinosaurs. If only they could talk. Snakes, bees, sharks, crabs, lobsters, yum, crocodiles, cockroaches, even green sea turtles. They all actually saw real dinosaurs. So jealous. Carnivore dinos mostly walked on 2 feet. That way they could be faster and have their hands free to grab a little snackosaurus. Plant eaters walked on 4 feet so they could carry their heavy bodies. Some of the bigger plant eaters needed around a ton of food per day, literally. Imagine animals so big they had to eat a house-sized pile of veggies on a daily basis. Still, a huge bush a day keeps the doctor away. Is that where that started? There are around 700 known species of extinct dinosaurs. Sounds like a lot, but we probably haven't discovered them all. 5 years back, they found out about a new type of dinosaur. It had these stubby horns right above its eyes, which looked so much like the comic book character. They named it Hellboy. Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice. In the 90s, scientists discovered a crater in Mexico's Yucatan Peninsula. You know the story. Around 66 million years ago, a meteor the size of Mount Everest hit our planet and filled the atmosphere with dust, gas, and debris that caused a serious climate catastrophe. It triggered a heat wave and a blast wave that went up into the atmosphere, partially blocking out the sun. Game over. Thanks for playing, dinosaurs. The age of humans never crossed over with the dinosaur era. Dinosaurs disappeared more than 60 million years ago, but they existed on Earth for 160 million years. Modern-looking humans have only been around for about 250,000 years. Only 59 million years to go, people. Not all the dinosaurs were on vacation in Mexico when the asteroid hit. They lived all over the globe. Some lived in deserts, while others lived in areas near ancient rivers surrounded by thick forests and rich vegetation. They weren't too picky, so they lived wherever, even Antarctica. But it wasn't covered in snow back then. Both poles had forests growing on them. Most people imagine all dinosaurs to be grayish-green because of the movies. Plus, we usually just think of them as giant lizards. Scientists still don't know much about dinosaur skin tones, but researchers recently found some evidence that dinosaurs totally embraced the rainbow. One little guy had white and orange rings on its tail. Dinosaur is Greek for terrible lizard. Scientists used to think dinosaurs were mostly cold-blooded like snakes, lizards, or other reptiles. Turns out they were wrong, maybe. Some evidence pointed to them being warm-blooded like mammals. Somewhere in 2014, scientists discovered that most dinosaurs were mesotherms, a little of this, a little of that. And it turned out many of them had feathers, just like little baby teeth. It helped them regulate their body temperature. Another thing we got from the movies and totally thought was real, what dinosaurs sound like. Producers usually mix together a bunch of animal noises to get that authentic dino roar. T-Rex is usually a mix of alligator, tiger, and the squealing of a baby elephant. And that dreaded T-Rex breath? It was just the sound of air going through a whale's blowhole. And here you are, on Earth, 66 million years ago. It's one of the warmest periods in the planet's history. There are no ice caps yet. Everything is lush and green. Dinosaurs roam the Earth. Massive sauropods peacefully chew on flowering plants and trees, their young ones following closely by their side. Ah. You strain your neck to see their heads 5 stories above you. But that's when you see something else. A bright spot in the sky. A shooting star. Make a wish. Wait a minute. The star grows bigger, brighter. Little do the mass reptiles know, today marks the beginning of one of the largest mass extinction events in Earth's history. 3/4 of life on our planet will be wiped out. Hey, we'll just hide over here and watch. 5 seconds before impact. The meteorite rips a hole through our atmosphere like a needle in a balloon. The resulting supersonic shock wave starts to ripple around the globe. You'd hear it on the opposite side of the planet. The cosmic monster falling toward the Earth is the size of Mount Everest, at least 6 miles wide and weighing 460 trillion tons. The meteor is coming in hot and fast, 12 miles per second, heading right for the Yucatan Peninsula in present-day Mexico. At that speed, it could travel from LA to New York in under 4 minutes. Impact. The mountain-sized asteroid smashes into the Earth. If only it had been anywhere else, life on this planet might look a lot different today. The Yucatan Peninsula, almost entirely underwater then, was one of just 8 places on the entire globe that would have let a giant space rock wipe out nearly all life on the planet, meaning the asteroid only had a 13% chance of causing a mass extinction, and it happened to hit just the right spot. Well, aren't we lucky? At the point of impact, there's an explosion 1 billion times more powerful than even the most massive volcanic eruption. It looks like a new sun has appeared on our planet's surface. The meteorite digs into the Earth's crust and explodes into 1 million pieces. You can still see the scar it left. The Chicxulub crater is 93 miles wide and 12 miles deep. It could fit the entire state of Vermont and 24 Burj Khalifas stacked on top of each other. Something that leaves a scar like that has global consequences. The Earth ripples. The shock wave spreads for thousands of miles. The air blasts flatten forests in a second. Everything within striking radius is set ablaze. Nothing survives ground zero. But that was just the beginning. Smaller fragments of the meteorite, as well as parts of the Earth displaced by the giant hole it dug, go ricocheting out, reaching as far as Canada. The sky lights up with fireballs. They smash into the surface as well. Dinosaurs that weren't in the blast radius run in panic, but they have nowhere to hide. It's only about to get worse. The shock waves race across the sea. The tsunami is nearly 1 mile high when it hits the coast. The waves keep traveling, reaching the furthest corners of the planet. Even across the Pacific and up into the North Atlantic, they're 5 stories high. They wash away everything in their path. Besides the raging fires and skyscraper-sized tsunamis, the Earth is shaking from the worst earthquakes in history. A planet lush and teeming with life only a few minutes ago has turned into a nightmarish place. But this was only Phase 1. 5 minutes after impact. Small rocks, dust, and ash rise high up into the atmosphere. These objects heat up and melt. They turn into hot lava that begins to fall to the ground like burning rain. 10 hours after impact. Fires continue to engulf everything in their path. Some surviving dinosaurs in North America try to escape to unknown territories, but now they're in dense swamps and can't escape. 1 month after impact. 15 trillion tons, 2.5 million times the weight of the Great Pyramid of Giza. That much ash and soot are released into the atmosphere. The cloud covers the entire planet and blocks out the sun. The Earth sinks into darkness. Surviving plants can't photosynthesize. Oxygen levels drop. Any animals left at this point are finally done in from lack of air. But the worst consequence was the extinction of phytoplankton. The entire oceanic food chain starts to collapse like a house of cards. Many marine animals have lost their main source of food. Surviving animals on land also can't find anything to eat. There are no plants for the herbivores, and soon no herbivores left for the meat eaters. And still, there's the acid rain. The Chicxulub meteorite hit a place where there was a lot of sulfur. The heat of the impact vaporizes the toxic gas instantly. It mixes with the air in the atmosphere. Acid rains fall all over the planet. The oceans become toxic. And if all that doesn't get them, the cold finally finishes off the job. With the sun blocked out, the burning fireball that is our planet starts to cool down. What's left in the wake? Plants are a little luckier than animals. Seeds and pollen are able to survive these harsh times. The first to slowly paint the charcoal planet green are ferns. The wind carries their seeds, sprinkling them across the earth over 10 years. Then come the palms. The new planets produce oxygen and feed small mammals. Of the reptiles, only turtles and ancient ancestors of crocodiles can survive the temperature and acidity of the planet's waters. Unbelievably, some bird-like dinosaurs survive too. Other species of birds evolve and survive to this day. Sadly though, all terrestrial animals over 50 pounds in weight went extinct. It took much longer for the animal kingdom to recover. Larger mammals, such as rhinos, began to appear only 15 million years after the dinosaurs disappeared. Blue whales, the largest living creature this planet has ever seen, bigger than any of the dinos, only showed up a little over 4 million years ago. Did the dinos have a fighting chance? Scientists say that if the meteorite had hit in the deeper ocean, the story would have gone a lot differently. Yes, the resulting tidal waves would have been 10 times higher than the already massive ones that rippled across the planet. But even a giant mega tsunami wouldn't be able to wipe out 75% of plant and animal life on Earth. What really did the dinosaurs in was the global blackout. If the meteorite had hit in deeper water, not the shallow sea of the Gulf of Mexico, there wouldn't have been so much dust and ash in the atmosphere. That dropped the oxygen levels and cut off the food chain from the very bottom. There's a theory that climate change and other conditions on Earth 66 million years ago would have still wiped out the dinosaurs, no meteorite necessary. It could be a supervolcano erupting and spewing out large amounts of sulfur and ash into the atmosphere. Perhaps the meteorite just sped up the inevitable. Now let's move on to a more interesting question. Could humanity survive a meteorite impact like that? Back then, not a chance, obviously. But if something like that were to happen in our time, we have an advanced intellect and technology. We've filled the cosmos with probes and satellites, so we know about any possible meteors headed straight our way. It wouldn't take us by surprise. Now, we might have to hide deep underground to avoid the blast wave and tsunamis, and you'd need enough food down there to last for at least a year. And don't forget your toilet paper. But with the right prep, humanity could stand a chance. The main problem after such an event is to survive the global winter when the ash covers the sky. But our species can handle it. Just ask anyone living in Oymyakon, Russia. The town of 500 people holds a Guinness World Record for the coldest inhabited place on Earth. They've seen the thermometer read minus 90 degrees Fahrenheit. What about preserving plant and animal life? Our species has been working on that for a long time. There's a World Seed storage facility on Svalbard Island. It's about 40 stories underground and can hold over 2 billion samples. The location was chosen because of the permafrost climate and low tectonic activity. Preserving all the planet's animals would be a tougher job. Perhaps genetic engineering, cloning, or something else would work. Herding them all down into a bunker? Crocs, bears, and snakes included? I think I'd rather try my luck above ground, thank you. Hello and welcome to the fight of the century. Today in our ring is Tyrannosaurus rex, the king of all dinosaurs that lived on Earth about 70 million years ago. T-Rex was one of the largest terrestrial predators ever existed. Even its name, Rex, means a king. And a round of applause for its opponent, Spinosaurus, a large lizard-like dinosaur that's 20 million years older than T-Rex. It can be recognized by the sail on its back. With its help, Spinosaurus could scare away predators and appear even larger than it actually was. And with that sail and tail, it was one of the few dinosaurs that could swim. We'll have 5 rounds plus a bonus round. The challengers will get 1 point for each round, and then they will step into the ring for a final battle. The first round is size. The biggest individual of T-Rexes was Scotty. Its legs alone were taller than a basketball hoop. And if T-Rex straightened its back, it would be taller than a 4-story building, bigger than the tallest diving board at the Olympics. It's the height of almost 7 adults. Its feet left footprints on the ground the size of a large dog. And although its forelimbs were only 3.5 feet long, T-Rex remained the most dangerous dinosaur of its time. Spinosaurus walked and ran, leaning toward the ground. It was longer than a school bus. Its skull was one of the largest of any dinosaur that ever existed and looked like the skull of a modern crocodile. It was up to 5 feet long. Spinosaurus had a sail on its back the size of an adult human. Its hind legs were much smaller than those of T-Rex and were only 25% of the length of the entire Spinosaurus body. Its tail was elongated and more massive than that of T-Rex because of the tilted gait. The long tail at the back had to balance the heavy body in front. So, Spinosaurus was bigger than T-Rex, and the first point goes to it. 1-0. Moving on to the next category. Wait, no, I mean how heavy. If we put T-Rex on one scale, we would need at least 4 big SUVs to balance it out. 14 tons. The heaviest land animal is the African elephant, but it loses to the ancient dinosaur twice. But for its bones, the weight could have been even greater. They were hollow, so T-Rex could stay fast and agile. Otherwise, it would be almost twice as heavy and way slower. When Spinosaurus ran after its prey, it caused a small earthquake. Its weight was 1 SUV more than T-Rex's, about 18 tons in total. And just like T-Rex, Spinosaurus had hollow bones, but it was still heavier than a large cargo helicopter. So in this round, Spinosaurus wins again, and the score is now 2-0. And the next round is agility. Spinosaurus's top speed was about 21 miles per hour. In general, modern dogs can run at this speed. The fastest man in the world, Usain Bolt, can reach speeds of 27 miles per hour. So, Spinosaurus could catch up with him over a long distance. But Spinosaurus was also one of the few dinosaurs that could swim. This gave it the ability to eat fish and the ancestors of modern stingrays. And if Spinosaurus was cornered by other predators, it could always escape and hide in the water. At the same time, T-Rex could only walk on the water as deep as its legs would allow. Scientists argue how fast T-Rex could run. Some say it was 11 miles per hour. In that case, Usain Bolt could easily run away from it. Another estimate is 45 miles per hour. At that speed, T-Rex could get from New York to Philadelphia in about 2 hours. It was as fast as a modern car. If you met a T-Rex in a safari jeep, chances are you wouldn't escape from it. Also, T-Rex was very maneuverable. It used its tail to keep its balance. And by turning its tail, it could turn and change direction very quickly. For that speed and agility, T-Rex gets its first score, 2-1, in favor of Spinosaurus. And we move on. Strategy. The strategy of Spinosaurus is hard to determine because of the variety of its food. It's somewhat similar to grizzly bears. Spinosaurus mostly fed on fish, and it got its food by grabbing small fish, rays, and other marine animals. Scientists claim Spinosaurus was highly intelligent because it would often eat things it was unable to get on its own. Yes, these dinos waited until some larger predators had finished their meal and feasted on leftovers. Something we still do at my house on Tuesday nights. The main tool of Tyrannosaurus was the jaw. It had the power of a crocodile's bite. That means it could easily break even very large bones. And you wouldn't be safe even if you were sitting in a car. That's enough bite force to bend metal. The second technique of T-Rex was ramming. Imagine a big truck coming at you at high speed. Such a battering ram could take down even a brick wall. Besides that, it had powerful limbs and a tail. It used them to knock the opponents off their feet and then hold them motionless on the ground. So T-Rex was a more brutal and capable fighter. It gets a point for that, and the score becomes tied, 2-2. And now it's time for the bonus round, the Audience Choice Award. Meanwhile, dinos are having a little break. T-Rex is a true pop culture star. You may have seen it in movies, games, and even memes. Once, T-Rex's face was even on postage stamps. And the world's most famous fossils? Of course, it's T-Rex skeleton in the American Museum of Natural History. But such popularity led to many myths about it. T-Rex could see motionless objects. You couldn't get away from it by just standing still. What's more, its eyesight was 13 times better than humans. And its sense of smell was excellent. It could track you like a hound dog. Unlike T-Rex, Spinosaurus is neither a movie nor a museum star. Today, there's no complete skeleton belonging to this dinosaur. Now scientists are looking for Spinosaurus's fossils. So, in the near future, we'll probably find out how epic this guy really was. The bonus round has no effect on the score, so we're still tied 2-2. The last round will decide everything. Combat tools. Spinosaurus used its teeth to get food. They were slightly bigger than your finger and as sharp as a needle. And there were 7 of them at the very tip of the jaw. But they were too short to do any damage to big dinosaurs. The rest of the teeth were deep in the jaw and were used for chewing. Other dinosaurs feared the claws of Spinosaurus. One of his thumbs could be as long as the distance from the tips of your fingers to your elbows. And this thumb ended with a sharp hook-shaped claw. These claws could leave a big mark on the skin of even the biggest dinosaurs. Now, let's look at the fighting tools of Spinosaurus's opponent. We know about the strength of T-Rex's bite, but it could have been even greater if their cone-shaped teeth had been stronger. They were the size of a large banana. This made them extremely sharp at the ends, but their enamel was pretty thin. Another tool were the claws. They were razor sharp and as big as a TV remote control. And its tail was so massive that its blow could knock down even a very large dinosaur. Time to let our fighters back into the ring. During the break, T-Rex chased a small dinosaur and ran out to the coast. Spinosaurus was waiting in the water looking for some snack. T-Rex rushes forward first. It reaches its maximum speed and tries to use its battering ram, but Spinosaurus manages to bounce aside. Agile T-Rex turns around quickly and knocks Spinosaurus off its feet with its massive tail. Then it tries to crush it with its foot. But Spinosaurus begins to swing its limbs around and scratches T-Rex. This gives it time to get on its feet. But in the next second, T-Rex bites it hard. Spinosaurus decides to retreat towards the water. T-Rex chases it until it's up to its neck in the water. It can't chase it any longer because it's not that good at swimming. Spinosaurus doesn't want to continue the fight and swims away to a safer place. And T-Rex wins this fight and takes the title of champion of all land dinosaurs. Are we off? Okay. Whew. Good thing the folks at home can't smell